12 years before the Wright brothers first flew, the pioneer pilot Otto Lilienthal wrote, "To design a flying machine is nothing. To build it is little more. To test it is everything." From defence establishments like Boscombe Down, Bedford and Farnborough, 45 service test pilots daily test military aircraft. This series is about a training school for those highly skilled men. 15 young pilots from the Royal Air Force, the Fleet Air Arm and 9 overseas countries will spend the next 10 months learning to test, flying a variety of aircraft far beyond the normal limits. They are students at ETPS, the Empire Test Pilot School, Boscombe Down. The secret experimental establishment at Boscombe Down is where most of Britain's military test flying is done. But just what makes a military test pilot? The popular image is the man who flies high-performance fighters, like the Tornado. Military test pilots fly thousands of hours to assess new aircraft, new weapons and electronics. Their job is to evaluate the aircraft in different roles, and then to decide whether average squadron pilots could reasonably be expected to fly them operationally. Test flying is not all high-speed glamour. This 30-ton dumper is part of a series of important trials to find out the maximum load that the new Mark III Hercules transport can drop safely. The load is a tight fit going in, and should it jam as it goes out, the Hercules is doomed. Dave Carpenter, the Hercules pilot, is a graduate of the test pilot school. That special training enables him to evaluate the tests in a way that a squadron pilot might not be able to.
This is the last sortie in the trial. We've got the heaviest platform that we've yet dropped. It's 30,000 pounds, and we've got the lightest aircraft weight, fairly light aircraft weight. So we're expecting, with the heavy platform and a relatively light aircraft, to get the biggest, largest trim change on the aircraft. So what we're doing is looking to see if there are likely to be any handling problems or problems with technique that could mean that it would be difficult to clear this particular load for release to the service.
The weather on takeoff is far from ideal, but an improvement is forecast. So the test begins with a 700-foot cloud base, the absolute minimum for the trial. This Hercules is a stretched version of the original, and no one really knows how it will handle as the 30-ton load moves along the lengthened fuselage. Dave Carpenter fits a special gauge, which will measure the forces the pilot has to cope with as the moving load upsets the aircraft's balance. The dropping zone on Salisbury Plain lies ahead in the murk.
100 yards left of the line, running parallel at minus 20. Drift is forced over. Right. Closing very slowly at minus 10, 9, 8, 7, 6. Red on. 4, 3, 2, 1. Green on. Green on. Extractor released.
Several slow-motion cameras will record the drop.
Deployed.
The extractor chute draws the 5 main parachutes from the aircraft.
Switched on, load moving, load gone.
A camera in the cockpit reveals how large an effect the load's movement had on the controls of the Hercules.
There was a peak force of around about 110 pounds. Still, for the very short duration of while the load is moving, it's only a second and a half, 2 seconds. That's not unreasonable, I think.
After analysis, they decided that the lengthened Mark III Hercules could safely drop a 30-ton load, the heaviest to date. All part of the test pilot's day-to-day work, like this VC-10 refueling trial. Once the runways at Stanley and the Falklands had opened, VC-10s could fly direct. But they had to be flight refueled, and since they were never designed for that purpose, a series of trials were flown by the Boscombe Down test pilots.
At high alert weights on the VC-10, we updrift the outer ailerons, as you can see in the airplane ahead, to unload aerodynamically in the wingtips. And what we are doing now is we are attempting a contact with both the tanker and the receiver ailerons, upset as we call it. And then we will repeat the exercise with them both in the north position to see if there is indeed any difference from aircraft handling point of view.
Now going over to box 1.
Roger. Okay, and red lights out. Okay, bucket is coming on. And trimming nose down all the times.
The object of the trials was to write a refueling handbook for RAF VC-10 pilots. The Royal Fleet Auxiliary, Sir Tristram, survivor of Bluff Cove, now recommissioned. A Sea King from the helicopter test squadron at Boscombe Down is to land on the ship, the largest helicopter she's ever had on board. The test pilots will have to decide if Navy pilots can also be expected to land Sea Kings on such a small deck. It may be thought that in this day of computers and simulators, a test pilot's role has diminished from the days of breaking the sound barrier and the exciting new aircraft displayed at Farnborough in the 50s. We asked John Farley, the chief test pilot who did much of the development flying of the Harrier, what is the role of the test pilot today?
Well, I think the job of the test pilot in the 1980s is exactly the same as the job of the test pilot was in the 1920s, or the 40s, or the 60s. I mean, quite simply, his job is to make every aeroplane that he flies as easy as possible to fly, as safe as possible to fly, and as good at doing its military job as is possible. And I think that applies to whether he's flying the first prototype for the company that manufactured the aircraft, or whether he's flying a service acceptance flight at Boscombe Down.
We require in MODPE in this country something of the order of 6 test pilots per year to be trained. That's an average figure, and these test pilots on graduation will move either into the trial squadrons at Boscombe Down or to Bedford or Farnborough.
That is the background to the annual test pilots course at Boscombe Down and the need for a test pilot's school. Competition is keen, and the entry list is always oversubscribed. All the students are hand-picked. They are above-average pilots with recent operational experience. Bob Horton, a Falklands veteran who spent a night in the South Atlantic following a tragic helicopter crash. Robin Tiedemann, Victor tanker pilot. Les Evans, Harrier pilot. And Alan Howden, Royal Navy helicopters. Jim Ludford, who has logged over 1,000 hours on Harriers. These and the other 10 men know that they face months of exacting and at times dangerous work. Why? Why do they want to be test pilots? We asked one of them, Dave Southwood, a Buccaneer pilot.
The variety of the flying was what really appealed to me, both in terms of the airplanes flown and also the exercises or the trials going on. That squadron flying, after a while, you can end up flying over the same piece of the countryside, flying the same airplane, doing essentially the same things. And test flying offered a great deal of variety. And tied in with that was also a desire really to know more about the airplanes and about the theoretical side.
The Test Pilot School, the first in the world, began modestly at Boscombe Down in 1943. From number 1 course to number 44, nearly 1,000 students have been trained, including many from overseas.
I don't know what the present price of a seat on that course is, but I'd be surprised if it was less than £250,000. And governments don't spend that sort of money lightly unless they think they're going to get some value from it.
Certainly not the French, who have sent Serge Aubert, a reconnaissance pilot. Most of the courses have had roughly half their students from overseas, and number 44 is no exception. J.T. Coe from Singapore, Harry Fail of the Luftwaffe, an F-4 Phantom pilot, Mike Micklejohn, a Canadian helicopter pilot, Mirko Zuliani, who flew starfighters in Italy, and from Australia, Nick Coulson, transport pilot.
Yeah, should be good fun.
Also Tom Coulter of the United States Navy, and Steve Moore, only the second New Zealand student since 1945. The 17 aircraft of the school fleet are made ready. There are 12 types, intentionally varied to provide a wide range of experience. They include this twin turboprop Andover transport and XL612, one of 2 Hunters which first flew in 1958 but are kept by the school as they are the only swept-wing jet aircraft in the world that are routinely spun inverted. In contrast, 2 Jaguars are flown to give modern high-speed navigation and attack experience. The 2-seater Lightning is for supersonic flying, and this complex aircraft contrasts with the Mark V jet Provost used for initial spinning instruction. There are 2 advanced trainers, British Aerospace Hawks. The helicopter fleet includes a Lynx, a Scout, a Wessex, and a Sea King. The rotary wing course runs parallel to the fixed wing. The fitters and engineers work on the aircraft to prepare them for 3,000 hours of student flying.
So that should be done when?
But first, it's ground school, and for most, the dreadful prospect of long-forgotten mathematics.
Well, maths is quite a hurdle for some people, especially if they've only got an O-level, and within about 10 hours instruction, we have to take them from that O-level qualification right through to approximately first-year degree level, in a fairly narrow subject area, but it's still a very steep learning curve. The workload throughout the course is high. There are not many free evenings or weekends, particularly for those that come with a low academic qualification. For those with high academic qualifications, at the early stages, then they have a fairly easy ride, but towards the later stages, they all have a very hard ride.
Though confident enough at the beginning of the course, the workload is severe, and soon some of the students may well be struggling.
Well, I think what happens is, tends to happen, the academic side builds up. It puts a lot of pressure on them. And some people, although have achieved a high standard in flying, are not necessarily the most natural pilots. They achieve the high standard through hard work. Now their hard work is being redirected into the academics, and there's less time to concentrate on the flying. So what you see is a falling of flying standards along with the academic standards, and together the standard goes down. It's a vicious circle.
The first lecture of 250 hours of ground school.
Gentlemen, this morning we're going to start a course on flight control systems. And during this course, we're going to be looking at the F-16 in some detail. I'm going to be using it as an example, not to teach you how to design flight control systems, but to show you the complexity of modern designs. While we should have been seeing an increase in the excellence of the control system.
James Giles, like all the flying tutors at the school, is himself an experienced test pilot.
As examples, one could look at the F-16 first flight, which was in fact never meant to be so. It was a high-speed taxiing trial that got out of control with a lateral pilot-induced oscillation, and the pilot simply put on full power, got airborne and sorted it out. I'd also like to cite the example of a Tornado, which crashed after many hours in service. It crashed on a landing, not because there was any fault in the control system or through any fault of the pilot. The aircraft actually crashed its nose wheel very heavily onto the ground, breaking the airplane because within the software there was a loop that he got into which got pitch acceleration in phase with his stick inputs. All these were examples of aircraft whose designers thought there was no problem. And yet there was. And that's what we're going to try to teach you, to look into those corners of those envelopes in modern flight control systems where you may find problems.
Now, elevator position is most important in spin recovery. When your elevator is...
Visiting experts are invited. Men like Darrell Stinton, an aircraft designer and civil test pilot, here to give a lecture on spin recovery.
Anti-spin rudder. And this is why we look, during our flight testing, at recoveries with elevator up and also reversed recovery with elevator down.
The subject of today's lecture is a subject dear to all your hearts, differential equations. We've got an example here on the overhead projector, and as you can see, it's a linear, second-order, homogeneous equation, one which you all will learn to know and love. On the chalkboard, we've got some examples of linear differential equations, starting with an undamped mass spring damper system. And for the electronic engineers amongst you, this is an electrical circuit. And this one, of course, you'll all be familiar with. It's Newton's law of cooling, which says quite plainly, the hotter you get, the quicker you cool down. And I'm sure you all want to do some further reading on this fascinating subject, and I can recommend this book, Mathematics for Engineers by Dull. It's the sort of book that when you put it down, you can't pick it back up again.
Well, the ground school itself is, again, a lot of work. It's a lot of reading, and the subject matter is not fantastically complicated, because we've got a very good tutor here who can put it over quite well. The problem is the volume. There's just so much of it. Because as you can imagine, the whole aviation subject is absolutely vast, whether you're talking about aerodynamics on a helicopter, engine design, goodness knows what. And there's just so much that you've got to try and take in during the course. And I reckon it's going to take me at least another year after the course is finished to reread all those notes. As you can see, there's a whole row of them over there. For a lot of guys, like myself, all failed their A-level maths, and that was about 12 years ago when I was at school. And of course, suddenly being confronted with quadratic equations and calculus was really mind-blowing. It was very difficult.
Not all the students pass. We hope that our selection procedure will give us students who are likely to pass the course, but one can never be sure. And there are two real stages of the course where people get into difficulties. And one is on adaptability on the flying side. You mentioned that we could be converting or could be flying somebody in the Jaguar who had only experienced heavy aircraft, and vice versa, fighter pilots encountering large aircraft like the Andover and the BAC-111 for the first time. Now, in the first few weeks of the course, we deliberately expose the pilots to a large number of types to check their adaptability. We don't give them long conversions to the aircraft, we give them minimum conversions to the aircraft, showing them that they can adapt quickly to different aircraft, that basically they're all the same, and provided they know the fundamental differences, then they can cope with the sort of flying that's required. Now, the problem is that some people are not able to rush from one aircraft to another. Unfortunately, those sort of people cannot really be employed as test pilots.
Always at the back of both tutors' and students' minds is the question of how a man, however good a pilot, will stand up to the searching role of being a test pilot. A role never called dangerous by the services, it is, however, conceded to be high risk. Are test pilots supermen, or mere mortals who can, like the rest of us, experience fear?
If they don't, they didn't ought to be test pilots. I mean, fear is a very, very necessary thing. I mean, my word, yes, if a chap doesn't have the greatest respect for any aeroplane he is flying, not just testing, but just flying, then he didn't ought to be an aviator. I mean, it's a very unforgiving environment, the air, just like the sea is. No, you must be frightened. You must know your limits, you must know the aeroplane's limits, and if you come close to both of them, you must be frightened. Otherwise, your chances of being successful or avoiding an accident must be greatly reduced.
The first flying on the course is converting the students, who have flown a wide variety of aircraft with their squadrons, to the school fleet. For even a student test pilot has to be able to fly any of the school aircraft without conscious effort, a bit like riding a bicycle. The Hawk is an advanced trainer, and the two on the school fleet will be used in many of the exercises. In contrast to the high-speed Hawks, the Basset, one of the few piston-engined aircraft the students will fly. This is no ordinary dog of war. It is unique and was specifically adapted for the training of test pilots at Boscombe Down. The French student, Serge Aubert, is to fly an exercise in the Basset, normally considered to be a most inoffensive machine. But this one, at the press of a button, can become difficult and bite. James Giles.
Well, what we use it for is as an airborne simulator. It is exactly that. We can actually take the classroom theory and let the student fly this aircraft to bring the theory into practice. We've had it now since 1972, and it's been a very useful tool. And what it does is essentially, through a computer, it modifies the behavior of the Basset, and we can make it fly like, essentially like any other aircraft that we want to make it fly like, within the restrictions of the fact it is a Basset.
So the control column there is really not connected to anything other than the computer?
That's right. This control column is just connected to the computer. There's an input from it measuring the pilot's force that he applies to the control column. So once the student flies this, and you can probably see that the existing aircraft control column isn't moving at all. And all he does is he puts his inputs through this. They're then modified by the computer, which in turn essentially flies the aeroplane. To change the configuration, that is the way the aircraft flies, what we have to use, as you can see down here, is rows of analog, we call them pots. Simply by changing the number set on them, changes a resistance in the analog computer, which varies that particular aerodynamic response. We can actually make it apparently unstable. As far as the student's concerned, it's still a stable aircraft because it's still a Basset, the host aircraft, but we can actually make it appear to the student as though it's unstable. So we can put him in a potentially dangerous situation, in an apparently dangerous aircraft within the existing safe airframe of the Basset.
For safety's sake, the Basset is not allowed to be flown via its computer below 3,000 feet. So the tutors perform all takeoffs and landings using the aircraft's conventional controls. Once above 3,000 feet, the student takes over and the exercise begins.
Right, Serge, what I'm going to show you now is a high yaw to roll ratio. And that means we're going to get a lot of yaw and not much roll. What I mean, I want you to roll out onto a heading.
This exercise is to give Serge experience of a common aircraft handling fault, the Dutch roll.
So normally we'd expect a Dutch roll to damp out well, nice and controllable. You have control of the aircraft and the computer. What I want you to do is put a small rudder doublet in, and then holding the stick central, just have a look at the natural response of the aeroplane as it comes around. And as you can see, it's gradually getting divergent, and there's the system cutting out, saying that probably the aircraft would have crashed had that been allowed to continue. Okay, have you rolled out on 330?
I rolled out, anticipate about 7 degrees. It took me about 4 inputs in L1 input to try to stabilize the Dutch roll. So it requests...
The Basset had been programmed to handle as a badly designed aircraft. Its ability to do this, within the limitations of the airframe, makes it an invaluable teaching aid.
Because the Dutch roll was excited, we saw the heading change, and certainly an HPR4 unsatisfactory. We'd like it to be much tighter than that.
Much tighter?
Yes.
Okay.
Things to remember about the Dutch roll. Firstly, there is a damping ratio, which is how quickly the motion dies down. There's a frequency, which is the speed of the motion itself. And there's the roll-to-yaw ratio, which is a measure of how much roll, how much bank angle to how much side slip. And those are the three aspects that you have to assess. And they're all important in their own way.
The 44th fixed wing course runs parallel to the 23rd helicopter course, with a good deal of interchange. But the rotary wing students have their own specialized training. And like the fixed wing pilots, they will have to develop a wide range of advanced flying skills. Mike Butt is the qualified helicopter instructor. He and his student, Andy Tailby, are preparing for an exercise to land the Scout in a very confined space. This is a conversion flight, for Andy is an experienced pilot. He flew the only Chinook helicopter to leave the ill-fated Atlantic conveyor minutes before that ship was hit by an Exocet missile during the Falklands War. The Scout is obsolescent. It has largely manual controls and a shortage of power, making the confined space exercise difficult. And the visibility is not very good either. But operational helicopters in Army service have to be able to land where they're needed.
Well, we're just about dead into wind at the moment, and it's getting pretty bumpy. Obviously that's going to help the power on the way on the initial approach, but certainly not when we actually get into the trees. It's going to be quite turbulent, so to be aware of the control response and the yaw limitations on this thing as we run into the final descent.
There was one low pass over the top there to identify the particular clearing. At the same time, in fact, we can also peruse the surrounds, shape, and also the surface inside.
Roger, okay.
Okay, if I had to come round to the left now fairly sharply. Clearing is now reached down there.
Okay. I didn't get a particularly good look at it then.
Okay, all looking round, there's no aerials.
The exercise is to test the limitations of the helicopter, not the test pilot, who will be taught to set aside his special skills and to ask himself, could this be done by a squadron pilot on operations?
Forward one. Forward a further one. And left one.
The figures are in meters.
Yeah.
I'd like to go tail
no, not really.
Okay.
No, we've got a very high tree. You have to come to the left.
Okay.
Bring the tail round to the right. Okay, vertical coming down. All clear this side. All looking good. Well clear this side.
Clearance on this side.
Right over the pad.
Okay, all right at the back there.
Okay, well clear behind. Sending on. All looks good. Okay, come left one in the hover. Left two. Left one. Steady. Okay, back one. Back one. Back a further one. Okay, steady there. Steady there. Clear down.
Yeah, it looks all right my side.
Okay, no further forward.
As course number 44 gets underway, 15 young men will learn a great deal about aircraft and even more about themselves. For the next 10 months, they will have to work harder than they now think possible. But at the end, they will have the skills to test an aircraft they have never flown before to its and their own limits. late spring, and Course 44 are flying their fastest aircraft, the 1,500-mile-an-hour Lightning. This morning, it is the turn of Jim Ludford on the right. His tutor, Tim Allen.
The main thing is don't relax at the end of the trip because we've finished doing the exercise. Remember, there's a fairly short runway and the landing is absolutely critical. And we must be down with 5,000 feet to go and do a precautionary landing from the word go. So if the chute comes off, we'll be able to stop in the runway length available. Okay, see the other side.
Tim warns Jim because the main runway at Boscombe is being relayed, and the alternative is slightly shorter than the minimum recommended for the Lightning. The Lightning, for all its complexity, lacks modern electronic flight control systems which are essential to fly today's fighters. Students flying the Lightning can therefore experience at first hand the effects of high-speed flight. The two Rolls-Royce Avon engines developed more power than a whole squadron of wartime bombers. Jim Ludford, Harrier pilot, is introduced to an alternative form of vertical takeoff. This exercise allows students to experience the effects of transonic flight, going through the sound barrier, if you like, without having a computer between them and the aircraft. Level at 40,000 feet. The Lightning, still one of the fastest fighters in RAF service, is delightful to fly and very popular with the students.
It's nice to fly an airplane with so much thrust.
Reheat produces enough extra thrust to accelerate the Lightning to 1,400 miles an hour, Mach 1.8, but at the cost of very restricted range.
That is by far the best airplane here. Unfortunately, we don't fly it as much as we'd like to. I've had a couple of trips, I think most of us have now, and that was tremendous excitement, actually.
Dated as the Lightning may be, the RAF still has two operational squadrons of them.
It's like a Mirage with two engines.
Because there is only one, flights on the Lightning are rationed.
Well, it's a bit like the forbidden fruit. You get shown a brief glimpse of it, and then it's taken away from you. I've flown 35 minutes in it. It was great fun, but I'd like a little bit more.
It was good fun. The type of thing that you look forward to.
But not the landing. The Lightning is known to the RAF as the frightening. The landing is the most critical moment. Jim Ludford makes a perfect touchdown and taxis in after the fastest flight he has ever made.
It's a delightful machine. It's a pilot's aeroplane. Just like a good car ought to be. It's not that big and it's got a great big motor in it, or two great big motors.
Although the Lightning is a difficult aircraft to maintain, being non-standard, they hope to keep this one airworthy for some years yet.
Okay, Jim?
Good. Yes, it was working well, wasn't it?
But I think we saw the rate of climb, supersonic, was down a bit on what it was subsonic. Yeah. On the other hand, we got to 37,000 feet at 1.35 instead of 0.9.
Still going.
So, and going well in the climb. So it looks as if it works well. Landing was nice, wasn't it?
I should say so.
Right.
Jim now has to write a report on his high-speed flight. Bob Horton is on the helicopter course. He is preparing for an exercise with JT from Singapore. They are working as a two-man syndicate. The Lynx is fitted with an electronic navigation system, which, like a home computer, has to be programmed.
Press enter. Okay.
The position of the waypoints, or geographical locations of targets, have been entered into the computer's memory.
Now what I'm looking for is a woods up on the nose, which I can actually see already, a finger-shaped wood, just to the left of the nose. And you see the little thing there, it's telling me there's the woods there. Okay, this is how we would normally wait now in ambush until the tanks actually come out onto the killing ground that's already been selected. As soon as they're visual, tell the aimer, who's JT in this particular case, to select whichever weapons he wants and then go for them. So now I've seen that, so I now set waypoint 3, which is the next one I want to go for. And the bar's telling me go that way.
It should be turning it now.
Yeah. So round we come now. As you can see, it's pretty featureless sort of terrain as well that we're going into. This is the killing ground, just coming into the area now, where we were actually going to go and take all the tanks out.
JT and Bob are to assume that the equipment is new, untried, and that they are to see if it is suitable for squadron use.
Okay, I've still got to get a waypoint 6. I've shot all these tanks.
The equipment is immune from enemy jamming. Accurate navigation at low level in battle means the helicopter spends the minimum time in forward areas and so is less vulnerable. This Jaguar 2 is about to be flown on a low-level exercise, but at 500 miles an hour. It is being flown to test the HUD, head-up display, with a related navigation system similar to the one fitted to the Lynx. The student is the Australian, Nick Coulson, a member of B Syndicate. It's going to be very different from the flying he's used to.
Yeah, it is. I've not done a lot of low-level flying in fast jets, no.
And of course it's strange country.
Yeah, well, that's what I'm wondering about. Normally in Australia you can see things from miles away, so I'm not too sure what I'm going to find.
Right, Nick.
The tutor, James Giles.
Very different from anything you've been doing before, right? And I know you're not familiar with the environment. Therefore, the way we'll play it is that I will do a lot of the flying for you. Okay, I'll actually fly the airplane to let you operate the system. So you're happy with the switches, you're happy with what the system is actually doing for you.
Yep.
So what we'll do, when we go over each waypoint, we'll actually do a plan fix. So from here, for example...
all 3 members of the syndicate will fly with the tutor before they fly the exercise solo.
And the sequence goes, plan fix, when you're actually overhead. I will note down in the back the time and the bearing and range.
Yep.
Then I'll call you to deselect it.
Okay.
Okay, you happy with that?
No, I'm not. I hit plan fix.
Yes.
Do I have to leave it there while you do that?
Yes, you do.
Or can I hit change this straight away?
No, you have to leave it there.
Okay.
You can change, yes, leave it there.
Okay, fine.
Okay. Now, I'd like you to stay low level in that. I know it's unfamiliar territory, but I'd like you to try to get a feel for the workload throughout all these things. I'll be monitoring you from the back, so there's no need to worry about actual terrain avoidance. So try to go for 250 feet. If you're more comfortable, obviously 400 or 500 feet, that's fine. But try to go for it. Try to keep the speed up 400 knots plus.
Mm-hmm.
Okay, What I want to just point out here is the waypoints we're going to. At least you've seen them then when we're going to. The lake's here, and that's the close-up map. The one we're actually going for, the dam, is that point there. There is a small lake just to the south of it, but that's the main lake for the main dam. Okay, so that's actually waypoint 5. The other waypoints all have vertical extent. The chimney, which stands out very well on the side of the hill, and that's the approach direction. So that is a tricky one. Al's Tower, you know, is on the ridge on the top of the hill. So those are the waypoints we're going to be going for. This is the Jaguar. Okay. I always recognise the Jaguar because it has one on the other and okay. You want to get up? I'll just go to the back seat.
Nick Coulson has spent most of his time flying heavy transport aircraft. The Jaguar will be a new experience for him. Before every flight, the pilot in command makes a careful visual inspection of his aircraft. This sortie will be at minimum height, 250 feet at 500 miles an hour. There is little margin for error. As the Jaguar lifts off the Boscombe Down runway, Nick switches on the head-up display to test it. The electronic navigation system is directing them to the first waypoint, a folly known as Alf's Tower. Right on track, even though the Jaguar is flying very low and very fast. On to the next waypoint, the lakes. The moving map in the cockpit shows that the lakes with the dam should lie dead ahead. The first lake and the dam. Zero error at this waypoint. The head-up display shows the speed, around 450 knots. Nick resets the system for the next waypoint. The track will take them past Glastonbury Tor. Finally, the system guides the Jaguar back to Boscombe Down for landing and the debrief. In the humid atmosphere, water vapor streams from the Jaguar's wingtips.
Right, excellent. Good, Nick. Two things. Firstly, I've got all the data for the alignment, and that was good. You saw rapid align after normal. Yes, that's right. As far as the accuracy goes, as you can see, absolutely super.
Yeah.
I wouldn't say it's unusual, but certainly for the inertial systems around
Because
here.
we did that rapid align.
Exactly, rapid align half a mile after 50 minutes.
Yeah.
So super. And as you saw, the regress store 35 minutes, 400 yards. So that really is the sort of accuracy that could take you to a target.
Yeah.
What do you think of it?
Well, it wasn't too much different than what we'd expected, but obviously the NCU is a bit of a pain. And
That's
looking
the
down
control
there,
unit. Right.
and looking down there is not very good news.
What do you mean by not very good news? I mean,
well, obviously looking into the cockpit when you're at low level reasonably fast.
Okay, Nick, are you happy to go solo with that?
Yeah, should you?
Bear in mind, there's a guy in the back, okay? Use him to take data.
Yeah.
Use him to look at. There are two of you, as I briefed. Make sure he's helping you look at.
Yep.
All right?
Yep.
Good. Thanks
Okay.
very much.
Thanks, James.
The American Navy student, Tom Colzer.
What we're going to do now is do the first part of the assessment of the test to determine the minimum control speed of the aircraft under asymmetric power.
The aircraft is a turboprop Andover.
And you will be increasing the rudder angle to keep the aircraft straight, looking for the rudder deflection and the rudder force. What we're looking for is when we get to 150 pounds foot force, when we've reached that, still wings level, and we are losing directional control of the aircraft, you may then apply 5 degrees of bank towards the live engine. So we'll slow down to 6 shaker in the configuration we want, which is 22.5 flap, wheels up. Apply full power with water meth, and then as it passes 102 knots, I will auto feather the number 1 engine. Then I want you to assess the handling requirements, the control forces you have to make, the control inputs to keep the aircraft under control. Are you happy?
I'm happy.
So if you're ready, I'll select the port engine auto feather facility on. Slow down now to the stick shaker.
Approaching, should be, there it is.
Okay, full power going on.
Okay, we're climbing and accelerating. Stand by. Mark for 102 knots.
Okay, failing the engine.
Left swing. Controls applied. Right rudder. Stick forward 102. Right aileron. Full right aileron. 5 degrees into the good engine. Climbing.
Okay. Right, and
150 pounds force.
Okay, it's down to 150 pounds.
Okay.
Right. Okay, so was it controllable at 102 knots?
It was controllable.
We only got about 25 degrees heading change and did not lose any altitude. Required initially a full right rudder, and we backed it off after we got the angle bank in to control it.
Okay, we will now pull the engines back again and relight that.
Okay.
Right, you ready?
Okay, I'm set.
Okay, right, off we go.
It's rotating.
This exercise is to discover how the Andover would behave if an engine failed on takeoff. Tom Coulter, like the other students, is now being trained to undertake difficult and at times exciting testing.
Well, every day actually is an exciting day, you know. Especially in the beginning when you have to fly a different aircraft, you know, and it changes very quick. You fly within 14 days, 6 different aircraft. The most exciting happening I had was my first solo on the Andover. I had 2 conversion rides before, and the third flight was the solo one. And I got hit by a lightning strike. The pitot boom fell off, and there was a big, you know, big light. Must have felt like, you know, several years ago in the Battle of Britain.
The second term of the year's course begins with a new aircraft joining the school fleet, a BAC-111, a second-hand airliner from Air Pacific, which had been strengthened for operations from rough island airstrips.
Come in, Mirko.
The Italian student Mirko Giuliani is to fly the airliner. Ron Rhodes, the fixed-wing qualified flying instructor.
I want you to do all the checks, you to behave as captain.
Okay.
So...
I didn't do the start yesterday.
That's right. Well, that's easy enough. And you'll find that we help. Even though we're asking you to be captain, we're still helping you. We'll go to flight level 245 today. We tried this yesterday. We haven't done this exercise very many times yet. Haven't had the aeroplane long enough. I want you to take over the aeroplane before you get to 0.75 mark. It accelerates really rather nicely. And I want you to see how fast it can go. So we'll do the normal start, and we'll do a standard takeoff between...
Mirko has had one short flight in the 111, which is by far the largest aircraft he, a fighter pilot, has yet flown. His task is to make an emergency dive from 37,000 feet to 10,000 feet. It is what would have to be done if the cabin pressure failed. The dive will be steep as the pilots reach for the safe oxygen level of 10,000 feet. A flight engineer joins the crew, making the surprisingly small flight deck very crowded. The Boscombe Down Tower slots this flight in with the scores of others from this busy airfield.
Clear takeoff, test the 56. Rotate. And V2.
Mirko, though unfamiliar with the big airliner, makes a perfect takeoff. And the 111 climbs on autopilot.
Landing gear is up, the lights out, landing lamps are off, and retract.
The 111, like all aircraft with high-mounted tails, can get into a stall from which recovery is impossible. So this first part of the exercise is vital.
You have control. I have control.
Climb it to, or keep it 150.
Hold 150.
Okay.
We do a stick pusher descent. Speed's about the same. Okay, closing the throttles then. Move the throttle across the set so we get the pusher as well. Okay, recover.
A maneuver that would have shaken the Martinis in a holiday jet.
And what we would now do is set ourselves up.
Mirko recovers the aircraft and climbs back for the pressurization failure dive.
Practice max rate descent, go.
As the 111 dived at the maximum permissible rate, any passengers not strapped in would have experienced weightlessness. Because the air pressure has failed, the flight crew have to put on oxygen masks.
I have control of the airplane.
To avoid overstressing this civil aircraft, one has to be careful pulling out of the dive.
All right, master off, back to normal.
Send you solo on that, Marco.
As the course progresses, the students will fly the school's fleet on more and more demanding exercises. But the ability to fly competently is only part of the tutor's expectations.
We are looking for much more than a simple ability to fly an airplane. That has to be there. The pilot has to be above average, if you like, has to have the affinity in an aircraft that he can relax in it, that he can almost, it becomes second nature to him what he's actually doing with the aircraft or what the aircraft is doing. So airmanship has to be an inbuilt into the pilot or into the test pilot. On top of that, what we're now looking for is a man who can put himself beyond what he's actually doing with the aircraft and look at what it in itself is doing, how he's interacting with it, how it's enabling him to do the job he wants to do with it, how it's making it easy or difficult in whatever fashion. So rather than blaming himself when the aircraft isn't going well, now we want a man to take himself out of that situation and look at why the aircraft isn't letting him reach the performance levels that he wants to reach.
The helicopter students also have to attain high performance standards, flying above, below and beyond normal squadron limits. The tutors never use the word dangerous, but the next exercise would qualify if they did. It has a rather sinister name, the avoid curve.
It's an area of the aircraft's flight envelope which the pilot must avoid staying in continuously if, on the circumstances of him suffering a sudden engine failure, he's going to manage to land the aircraft safely. And it's usually defined by a height and an airspeed combination. If the pilot should have an engine failure within those areas, the chances of him getting away with a safe landing are pretty remote.
As this American test pilot was to discover. This film is shown to the helicopter students as part of their avoid curve lecture. It certainly makes their tutor's words seem inadequate.
It is a critical area. It's an area which you will not have flown before, an avoid curve. You will, as throughout your training, throughout your operational flying, have carried out engine off landings, at least at some stage, but you will never have looked at landings on the edges of the avoid curve, and you will certainly not have tested at some of the more critical areas of the avoid curve. Remember, at all heights below 200 feet, coordinate the throttle closing and the lever lowering carefully. Make sure on touchdown there's no side drift, skids are level, and the minimum ground speed, as I said, 5 knots. Any questions so far?
Ian, tell me, in the past when you've done this, what sort of problems have you found when you've been trying to close the throttle and lower the lever at the same time?
Good point, that, Bob. As you know, you do require quite a handful of throttle to get it fully closed on the Scout. What you have got to avoid is, while you're doing that and coordinating it with lever lowering, that you don't make an inadvertent rearwards movement of the cyclic. If there are no more questions, we'll go away and fly the exercise. Thank you very much. Thanks, Ian.
The first student to fly the exercise will be Bob Horton.
I gather this is called critical testing, Bob.
Well, it is, to use the correct phrase, yes. Personally, I think it's bloody dangerous. If you did this on a squadron, for instance, you'd end up being court-martialed, I reckon. I'm quite looking forward to it, really. As you'll probably remember from the classroom, I was asking about the difficulties of closing the throttle and getting the lever down at the same time. Perhaps I could just show you here. Basically, when you're flying along, you're in something like this position with your left hand controlling this lever here, which we call the collective, and your right hand here on the cyclic stick. Now, for the purposes of this exercise, we're simulating the engine failing by closing the throttle, which actually involves a movement something like that on the throttle lever, just like so, and at the same time trying to lower the lever. And in some of the situations, you can probably see that if you're flying along normally like so and try and do it, you end up trying to fly the aircraft with your hand kinked in, like so. So it could be slightly difficult, I don't know. I'll have to go and find out exactly what it's like.
Mike Swales, like all the tutors, is himself an experienced test pilot. He is to supervise the test flight, which, if done only slightly incorrectly, as the American one was, could write off the helicopter and endanger the lives of the crew. The Scout is an old design and has no automated controls. As it has to be flown manually all the time, it quickly reveals any ham-fisted piloting. But Bob Horton is a very experienced Navy pilot. Bob hasn't far to go, for the exercise is flown over the Boscombe Down airfield.
Okay, get yourself nicely stabilised, make sure everything is clear below you. Yeah. And then on your own countdown, 3, 2, 1. Now, I want you to close the throttle and lower the lever immediately, correct the yaw to the right, and to drop the nose nice and smoothly in order to regain 50 to 55 knots before bringing the nose back to a level attitude, ready for the engine off landing at the bottom. Okay, Mike. Any questions? No, I'm happy with that, Mike. Okay. Happy with that. Okay, bring this to a virtual free air hover then. A lot of power, a lot of left boot in. And 3, 2, 1. Okay. And nose going right forward, airspeed coming back, NR recovering very slowly. About 50 knots.
The critical moment. The only way now to cushion the landing is to use the energy stored in the freewheeling blades at precisely the right moment.
A little bit more, and so now there we are.
Bob Horton was asked about the exercise.
Well, different, I can tell you. I'm still alive anyway, so it obviously went not too badly. And it was good fun, actually. Very enjoyable, and learnt a lot from it, actually.
It's not over yet, for to complete the test, Bob will have to make some 10 descents at differing heights and speeds to establish the Scout's avoid curve.
Coming up, 50 knots. Leveling, watching the NR, and holding her there. Okay, run complete.
For the fixed-wing students, the most testing exercise
...20,000 feet. Recover now. ...10,000 feet. If not recovered, eject. Eject.
Since man first took to the air, one single maneuver has killed more pilots and destroyed their aircraft than all others put together: spinning. All aircraft can be made to spin, but not all aircraft can be made to recover. This one is spinning intentionally. The pilot applies the correct technique and it safely recovers. A Jaguar being tested. The engine cuts or flames out and the aircraft spins in clouds of unburnt fuel.
Why do we need to carry out spin testing? First of all, it's a useless flight mode. Secondly, it's been of no tactical value since the First World War. And thirdly, many of our frontline aircraft operate at levels below which they could safely recover from a spin. I think it's quite clear then that it's important that we must establish that when an aircraft will depart from controlled flight, so that frontline aircrews can fly with confidence to the limit of the flight envelope. In the event that the aircraft then does depart from controlled flight, we, the test pilot, must have established ways by which their aircraft can regain controlled flight again. Remember that spinning can be confusing, disorientating, and an uncomfortable mode, especially if you didn't expect to be in a spin to start with. Now, I'm going to show you some film clips from various spinning trials.
What I'd like you to bear in mind during this film is one factor, and if you go away from this lecture with one factor alone, we will have achieved something. And that is that whenever you're spinning, be prepared for the unexpected.
An American Buckeye trainer.
The spin was intended to be 4 turns. If you count closely, you'll see that recovery didn't occur until 33 turns later. And the reason for this delayed recovery was never found.
As the pilot tried to recover, the Buckeye reversed the direction of its spin from which recovery was possible.
This next clip is of an F4J. It entered a flat spin after the first 2 turns. Notice the ineffectiveness as the spin parachute as it gets caught up in the wake turbulence from the aircraft. There's a good learning point here. Always ensure that spin chutes are on long enough cables and fired well away from the aircraft such that they can be effective.
The ineffective anti-spin chute intended to stabilize the aircraft is jettisoned. The F4 spins on to destruction. Is all spinning dangerous?
We tend to shy away from words like dangerous because we don't embark on anything unless it's truly thought out. But there is always that area of uncertainty, and in spinning there is perhaps the highest proportion of uncertainty. So we'd like to call it high risk rather than dangerous. But in general, once the aircraft enters the spin, it's a very disorientating motion, and pilots are not normally used to it, which is another reason we train here, that the more often you see the spin, the more likely you are to be able to recognize the problems and recover.
A jet provost is based at Boscombe Down for spin training. Surprisingly, few service pilots have recent spinning experience.
No, actually, I spun only once in my life so far, and this was during pilot training about 10 years ago.
Yep, I think we're ready to go. Let's just check to see if there's any unserviceabilities on the airplane.
Vic Lockwood signs the traditional RAF Form 700. The aircraft is now his responsibility.
Please don't break it.
You're going to pay for it.
Okay, let's go. Okay, this is your first trip, Harry, in the JP, and we're going to have a look at all sorts of things in the spin as well.
Okay.
So, rather than confuse you with too much of the technical detail, I'll look after most of the limits, and I'll remind you of all the different flying limitations as we go, so that we can actually concentrate on the spinning.
The Jet Provost is not a pleasant aircraft to spin, and 12 of them have been lost in RAF spinning accidents.
Okay, if we just put our helmets on here now. We're running a little bit behind, so what I suggest is you get in and check the seat. You're used to the seat. We've been over that before. Yeah. So you check it and climb in and get strapped in. I'll walk around and make sure all the airplane's there, and I'll see you back in the cockpit.
All right.
All pilots have to be familiar with the ejector seat, which is fitted to the aircraft they are about to fly. Harry Fail, the German student, straps in. He must remove the safety pins to arm the explosive ejector seats. If a single pin is left in, that seat will not eject. So the pins are placed in a rack, which both pilots can see and check.
Watch him strap in.
The Jet Provost first flew as long ago as 1954. It has manual controls which need considerable physical strength to recover from a spin. After takeoff, Harry climbs to 16,000 feet.
Nothing below us. Good. Okay, right about here. Oh, Jesus Christ. The rotation rate increases and is oscillatory. It's very difficult to hold the stick forward. Okay, opposite rudder then. Rudder comes opposite in now. It's very difficult to recover the aircraft like this. I mean, you must be a real muscle man. Center and pulling out. Okay, you got a good engine.
87 miles southeast to you now.
Interesting, isn't it? Quite wild.
The next aircraft in the spinning syllabus is the Hawk Advanced Trainer, a much more modern design, but one with some unpleasant spinning characteristics, which are somewhat worrying the New Zealand student, Steve Moore.
Is there any danger of the actual spin becoming inverted, or the aircraft becoming inverted?
Well, the spin does get agitated, and I suppose of all the spins that we do, that is the one that there is a chance of it going inverted. I don't know of one Hawk going inverted. However, if the aircraft does enter an inverted spin, I'd like you to take the normal control positions for recovery. However, there is a warning in the aircrew manual that there may be excessive forces on the rudder. So you may have to physically constrain the rudder pedals to the neutral position. And then I'm afraid we'll have to see what happens from then on in.
I'll get you to help me with that.
I'll do my best.
Because spinning is very disorientating, to reduce the risks, the school aircraft, which operate way outside normal RAF limits, are fitted with a radio link which transmits data to a backseat pilot at Boscombe Down. All the readouts from the aircraft spinning 25,000 feet above are duplicated for the pilot on the ground. If his airborne colleague gets into trouble, the safety pilot can advise on recovery action. Steve Moore and tutor Vic Lockwood walk to the Hawk. The weather is good. It has to be, for even at the test pilot school, spinning is only permitted with the ground in sight. Unlike the Jet Provost, the Hawk, though dual-controlled, does not have side-by-side seats. The student sits in the front seat. Spinning imposes severe stresses on the airframe, and any loose panels could jam the control surfaces and prevent recovery. So the visual checks are especially thorough. The flaps are checked, and so are the ailerons. Later, they're going to cause Steve trouble. The Hawk, like most of the school's aircraft, is fitted with additional instruments which show the actual position of the control surfaces. Both student and tutor can see exactly what the pilot has done. The intake guard is removed and the engine started. The radio link to the Boscombe Down safety pilot is tested.
Testing 71, transmit on. Tester 66, transmit on.
66, next spin direct to the left. From my left turn entry, your brakes in, forward turn.
25,000 feet below, the telemetry antenna tracks the Hawk, and the ground pilot confirms the details of the first spin.
Neutral and normal recovery.
That's affirmative, and 66 is 1 minute to the spin.
Tester 66, transmit on.
In New Zealand, Steve Moore flew Strike Masters, an armed version of the Jet Provost. This is his first spin in the Hawk.
Full left rudder, I have heard through on all of those. Full right rudders now on.
It is far from smooth, but that is normal for a Hawk, and Steve recovers without difficulty.
Oh well, that's good work, try.
Pressure is recovered.
Spin number 4 will be erect to the left from a level entry, 4 turns, applying in-spin, not at a hesitation, for a normal recovery.
Back to 25,000 feet for spin number 2. This time, it goes wrong. Very wrong indeed. Inadvertently, Steve is applying a little outspin aileron, turning the Hawk away from the direction of the spin. It nearly goes into the forbidden and dangerous inverted spin. Vic Lockwood sees the fault, takes over, and recovers the aircraft. On the ground, the pen's traces record the details of Steve's error for the post-mortem after the flight. Steve makes several other spins without further incident and quickly regains his confidence. In a spin, a jet aircraft's engine can flame out and be impossible to relight. To train for that, should it happen on his solo spin, on the return to Boscombe Down, Steve makes a practice dead engine landing. With the engine at idle, the approach has to be steep in order to keep up safe flying speed. With a dead engine, there is only one chance. Judgment has to be perfect. Next, the debrief.
I always say always be prepared for the unexpected. And during what was a fairly straightforward entry to a spin, in fact, the Hawk almost went inverted on us. And the reason for that was that the student had not followed directly the instructions I had given and had sneaked in some outspin aileron at the wrong moment. And it's then that you have to think quickly and recover. Then we go back and try it again. I think he learned more in that sortie than he will ever admit. I think he felt a little chastened after a while when his entry techniques were not consistent. But by the end of the sortie, he'd regained his confidence because he'd overcome that problem.
Well, when I entered the spin, I had a small amount of aileron input. The stick in the Hawk, the way it slightly canted over to the left. So what I was doing, two hands on it, which is a bit of a habit-forming thing with me because of the strike master's got fairly high elevator forces. So to relieve the load on the arms a bit, I used to pull back with both hands, and I think I was doing that with this. And as a result, that canted bit of the stick holding the top, I was bringing it into the middle. That could have been it. That's my excuse anyway.
The final exercise is spinning the Hunter. It is unique to the school. For an RAF service, spinning a Hunter is not permitted.
We are, in fact, the only course that spin swept-wing aircraft. We are lucky to have an aircraft which we can spin both erect and inverted in. Perhaps I can explain to you what I mean by erect and inverted. This is a model of the Hunter. In an erect spin, what is happening? The aircraft is travelling down a vertical path, and in doing so, it is rolling, and it is pitching, and it is yawing, and therefore it is taking this sort of motion. Now, that's an erect spin, because you can see quite clearly the pilot is still sitting upright in the cockpit and is experiencing these motions. And so the forces are in the normal sense, from head to toe. If we look at inverted spinning, the airplane is in fact spinning upside down. So it's still pitching, it is still rolling, and it is still yawing, but the pilot inside is upside down, and the forces are being felt from toe to head, so the blood is moving towards the brain. It's very difficult to follow, but the aircraft is rolling and it's yawing. If you see now, I'm rolling towards the left, but if you watch, I'm yawing to the right. So the roll and the yaw are in opposite directions, and that can be very, very confusing.
Confusing enough for the RAF to have lost 29 aircraft in spinning accidents in recent years. The student about to spin the Hunter is Dave Southwood. His brief is to suppose that the aircraft is new, about to enter service as an operational trainer, and must therefore be cleared for students accidentally getting into spins. The school Hunter has special instruments which can help a pilot to recover from a spin should he become disorientated.
You can get disorientated in the spin. Certainly it's an exercise or a flight regime where you do need a fair amount of practice to stay familiar with it. But again, it's one of the things we're looking at the airplane for, to see how disorientating it is. Because if it's too disorientating and confusing, then there's no way you can let solo students go off and spin it.
As the Hunter climbs, Dave switches on his cockpit voice recorder, which will help him analyze the exercise later.
Looking for oscillations and any engine problems, and comments on the rudder forces as it goes oscillatory. For us R1 and entry. Hesitation after a quarter of a turn, nose to 30 nose down. Second hesitation just after one turn. Waiting for the next hesitation. Going there. And going out, spin aileron. Missed the second turn side end, that's 3. Going more stable, nose about 40 nose down. There's the oscillation. Feeding in the aileron. Becomes very steep, nose down. Nose pitching up to about 20 below the horizon. Rudder trumping off the stops. Wing tilt angle increasing about 40 degrees during the oscillations. Going very slowly, pitching for about 45 nose down. Engine now 6.3, JPT still 400.
On the ground, Vic Lockwood, acting as safety pilot, has noticed a problem.
Engine is beginning to overtemp. Check engine, check your engine.
And recovering, centralised ailerons. Full off.
Dave Southwood does and acknowledges.
Is recovered.
And recovered. And the RPM's coming back about 6,450. I think JPT's coming back to 400. Tights will be good.
The aging Hunters at Boscombe Down remain the only swept-wing aircraft in the world that are routinely spun inverted. As always, Dave will have to write a lengthy report.
Spin 1, direct spin to the right from a level entry. 1 turn, neutralising.
His recorded notes are a help, but the workload on the test pilot's course is very high.
Yes, it is a high workload. We do expect the students to spend a large proportion of their own time actually working at producing reports, and it's very much self-pressure. It's up to the individual, really, how much time he puts in. Everyone's going to have to put in a lot of time, but some do put in a lot more than others, yes.
90% of the course, I would say, is involved in writing up these reports here. Because as you can appreciate, after every flight, we've got to sit down, analyse all the data that we've taken, and then try and put it together in English so that somebody else who's not necessarily connected with aviation, a scientist or whatever, can actually understand what we found in the air.
It was one of those things that everybody said when we started the course that it would be a very hard-working year, and that you'd sit there working till 1, 2 o'clock in the morning. I didn't really think that it would be possible to work till those sort of hours and get up and do a normal working day the next day. But I think from that point of view, I've learned a lot about myself from the work side during the year. The fact that you can work sometimes till 3, 4 o'clock or even all through the night, that you can work to that extent and basically carry on. So you do find out how much you really can do.
When I was going through the course, yes, it was the morning of my 30th birthday. I got up to take a shave, and for the first time in the morning, I looked in the mirror, and there, to my horror, was this old man looking back. I'd aged about 10 years on the course.
The sight and sound of the past, a Pratt & Whitney air-cooled radial engine. It is powering a de Havilland Beaver, borrowed from the Army Air Corps, for an exercise in stability which, though not as risky as spinning, does involve stalling the big Army monoplane. James Giles and his American student Tom Coulter take off to investigate the handling of this high-wing monoplane of dated design.
You'll never make a silk purse out of a pig's ear like this airplane. You wouldn't want to. It would take away all its character.
Yeah. Well, that's one thing to be said about this type airplane. The harder they are to fly sometimes, people get more personality with them. They like them better.
So if you'd like to go into a progressive steady heading side step now, so that you go all the way through to full rudder. We know we can, so...
Okay, well, we're coming on with the right rudder.
Okay, right rudder. Okay, so we're immediately seeing that right rudder's generating right side slip.
Right side slip.
And a lot of left aileron required.
Back.
almost full left aileron. We're sitting on our sides now, 35 degrees angle of bank. And kick off the drift quickly and we'll see how much side of angle we got from heading 110 to 085, about 25 degrees of side of angle.
And now the stall exercise.
Let's come back into a stall from there. Speed's dropping down now to, well, you talk us through it.
Okay, we're down to 55 knots now, speed's dropping back down. Ailerons are very light, and we're starting to use a little rudder for directional control. Fight. There's 40 knots. Easing the nose up. A little buffing on the elevator.
Keep it coming back. Keep it coming back, 35 knots.
And it breaks
and
off
there's
to
the
the
stall.
right.
Breaks off down to the right.
Lower the nose.
My power to recover.
Bring the nose back up to about 65 knots and climb away.
Okay. Right, so we can see that we're carefully going to stall it again.
Yeah, working on it.
As one stalling exercise ends, another begins, with the Andover taking off from Boscombe Down. The heavy transport is being flown by the helicopter student from Singapore, JT, with tutor Colin Wilcock.
Got the indication. Try the controls now. I mean, if the guy is not trying it, you will know that it's getting sloppy.
Yes.
The aircraft staying level. Because there wasn't any wing drop, so there's no need for a pilot to...
Okay.
The students on both the fixed and rotary wing courses have to be able to fly each other's aircraft.
This side. This side. Oh, just...
Mirko Zuliani, the Italian fighter pilot, is to fly this Lynx. The instructor, Mike Butt, does the takeoff. The exercise is to show Mirko how to make an auto-rotational descent, that is, without engine power.
Right, Mirko, do watch the torque variation and do watch the amount of pedal you have to put in when you bring in the lever at the bottom of the auto-rotation. Okay, so I'll hand over control to you and then we'll go straight into one to the right. Okay, you have control. I have control. That's good control.
Meanwhile, JT, the helicopter pilot, is being instructed in the art of stalling the Andover.
Have a look at what happens when you get closer to the stall, finally going into the stall itself, and then recovering from it. Right, as you get down towards it, you're still out of it now, just have a look at how effective the controls are. Okay, and the rudder. Okay, now let the airplane decelerate till you get the buffet. Let it keep coming down now, we'll just go straight into a stall. Okay, airframe buffet. Right, now recover. Recover, steam forward. Okay. Roll it level. Pick up the wing, so get out of the stall.
JT eases the transport out of the dive, as Mirko, jet fighter pilot, makes his first helicopter landing.
Get a bit of left pedal as you come down. That's it. Pump. There we are. Super. That was very good.
How was the sortie, Mirko?
Interesting, but strange, you know. It's the first time that I flew with this helicopter.
At the end of the summer term, there is the staff wash-up, a confidential meeting to discuss the students' progress, or otherwise. We asked tutor James Giles for his opinion of the course so far.
Well, it's like all courses. There are one or two who are very good, and very good indeed, in fact. They're showing a lot of imagination in the air, they're planning well, flying well, and really on top of it. At the other end of the scale, there are one or two who are having problems with adapting to flying as a test pilot. They can fly perfectly well, as they're perfectly safe, but they're having to work very hard at actually being a test pilot.
And I think that if you were to see the chaps at the beginning of the course and now, you will see that they are visibly tired and aged because of the pressure that's upon them. And so the biggest problem, from the staff point of view, is knowing just how far to push these chaps.
As it always has, the summer term ends with the traditional cricket match, the staff versus the students. The staff are batting. Lockwood, Court and Bold, Ludford.
You catch the roads so far?
Yeah.
Serge Aubert bowls from his short run.
Run! Yours, Les.
The boss gets a single. The score is irrelevant. The staff have never lost the fixture since it began in 1943, partly because the overseas students are never given the rules.
No, what's happening now?
Some change? How is it?
There's always a lot of change, but you never notice who changes with what.
In fitful sunshine and increasing rain, the students bat. They have to be careful, being understood that any student getting into double figures is placing his future in jeopardy. Not that any do. Dave Southwood takes off on the wrong runway and is out.
Great.
Harry Fail, last man in, is prepared to save the match.
I prosit, I prosit. That end, Harry. Do that end, Harry. Come on. Ready?
Alas, the Germans... The final term has started. The students of number 44 test pilots course can fly all the school's aircraft. Now to gauge them for what they are, weapons of war.
Okay, what we're going to do on this exercise is we're going to assess the Jaguar inertial system. And we're going to assess it for its operational aspects. Right? And that's what you've got to start right from the beginning thinking. This is an operational aircraft. Its job is to go to war. Your job is to assess the aircraft. How well can the operational pilot fly it? How well can he use it? How well does it help him to find small targets and to drop the weapons on it? That's the game we're in today.
All the students have flown the Jaguar on the low-level navigation exercise with a tutor. Now they are to fly it on their own as a test team. Two of the syndicate, Les Evans of the RAF and Nick Coulson of the Royal Australian Air Force, are going to look at the Jaguar's inertial navigation and weapon aiming equipment at high speed and minimum height. Today, Les is the pilot, with Nick his observer in the rear seat. The exercise is not a test of their ability to fly the Jaguar, that is now proven, but to assess how well the guidance system performs under simulated battle conditions. Their Jaguar, XX-145, begins to roll along the long Boscombe Down runway for takeoff on the low-level exercise. When it is completed, the student test team must make a formal presentation of their findings. To help the team prepare the presentation, Les and Nick will record the details of the exercise.
So you really want a few more details on the map for that. There isn't much on the map. It's fine if you're in a detailed area, and also lots of stuff on the ground.
The moving map is showing the Jaguar's present position as 1 mile southeast of a waypoint, the two small lakes.
Okay, I can just make out the lake. It's actually hidden slightly behind that hill, but the cross is very close. And the map's slightly out. It's probably half a mile out, I'd say. Okay. Coming shortly and updating now.
The equipment also gives course, speed and distance to the next waypoint, Alf's Tower, and updates with exact latitude and longitude.
Okay, I can see Alf's Tower coming. Yes, the kit's looking quite good. Okay, updating now. Okay, next target run.
Next, the weapon aiming trial using the head-up display. The simulated target, a dam in Wales.
See the target area ahead. Our updates have come up to it. Kit's looking quite good again. It's pretty good. It's stabilised on one point, but it's not quite the right point.
Okay.
Okay, waypoint 3 next. That's looking quite good, actually. Got the mast out to the right-hand side. Uplifting now.
The radio tower waypoint.
Okay, going back to Boscombe.
They are guided back safely by the electronics. But on approach to the busy airfield, they still need an old-fashioned lookout as well.
See the Hawk downwind, and at the end over on Long Finals. Braking. Average. Down.
All three of the syndicate have now flown the exercise as command pilot. Les Evans was the last. They have already decided that they will be making certain recommendations about the equipment at the presentation.
Well, the major recommendations were twofold, really. The navigational control unit, which is this box down here, which sits between the pilot's legs, was too low down for him to reach easily in flight. When he's flying at low level, his eyes really want to be outside the cockpit, looking up at about this level, and the navigation control unit is set way down here, and to look at it, he needs to actually look into the cockpit and reach forwards to operate switches on it, which he must do in flight at low level, which is not desirable.
One of the other recommendations that we made was this WAMS panel, the weapon aiming mode selector over this side. We found a little hard to operate because of the size of the buttons. We found that with a gloved finger, you still had to look at the panel and make sure you press the right button, because it's quite easy to operate the wrong button. The labelling's not terribly good, and in a high workload situation, it was reasonably easy to make mistakes.
The other point was the field of view, this head-up display, which is basically...
Serge is criticising the head-up display. But wouldn't Jaguar squadron pilots have noticed the same defects?
I think operation pilots are equally well aware of the limitations of the systems, because they are using these every day, and they're fully aware that that panel, for example, is in the wrong place. It's far too low. I'm sure all the Jaguar pilots are aware of that. I think what we're being taught to do is not just to say it's in the wrong place, but explain exactly why it's in the wrong place and exactly what aspect of that panel is used in flight, so that subsequently people can say, well, we won't move necessarily the whole panel, we'll move these switches from it. And it's that sort of analysis that we're trying to be taught here.
Working in the ground school, the three student test pilots begin writing up their first 30-minute presentation. They will have to deliver it before a highly critical and knowledgeable audience of tutors.
But I understand that we don't have to do that. It doesn't matter whether you've got,
They know that every detail of the presentation must be beyond reproach. But there remain other duties to be fitted in. For example, the visit to British Aerospace at Hatfield, one of several such trips to industry and service experimental establishments at home and in Europe. The visits are popular, and already the students are looking at prototype aircraft with different eyes, the eyes of test pilots.
And after that, leave them first. If you see a fighter pilot in a transport aircraft, he's always very high.
Mirko Zuliani and Serge Aubert, after two-thirds of the course, are now skilled enough to be able to constructively criticize aircraft.
Looking at this aircraft, I mean, I could see this as a good replacement type thing for the Hercules.
Yeah, that's right.
That's going to be no great problem, though, is it?
Certainly not. The track of the landing gear is larger than the Hercules.
The students are encouraged to discuss technical details on equal terms with the company test pilots and engineers.
Right hand doesn't matter. So you've only got to keep one door on the shelf rather than two.
The reason for the visits is to let service test pilots get some idea of developments in the aircraft industry. On the other hand, it lets the constructors meet the military test pilots of the immediate future. Back at Boscombe Down, the Lynx is prepared for an exercise suggested by JT from Singapore. He wants to see how the helicopter handles with autopilot AFCS failure.
I'm going to simulate stick trim failure.
Okay, well, with the ASC failures then, the AFCS failures, what sort of things are you going to be looking at? What are you going to be assessing when you fail one of the lanes?
But Mike Swales, the principal helicopter tutor, wants further details. Lane failure means failing entire sections of the equipment.
Now, you're just doing single lane failures, or are you using... you're going to evaluate the aircraft with a total AFCS failure?
I'm going to do both.
The visor JT is wearing prevents him seeing out of the aircraft. He can only see the instruments. He must fly by them. Mike Micklejohn and Bob Horton are to fly with him. The object of the flight is to see if the Lynx can be controlled on instruments alone without the autopilot, yet still remain suitable as a VIP transport.
Try and disengage your AFCS using the AFCS cutout.
Okay, I'm simulating a doubling failure by inadvertently...
The autopilot is disconnected.
Okay.
Here I am, controlling the aircraft pitch.
What's happening now is he's flying the aircraft purely without any stabilization on it at all. It's just a raw helicopter apart from hydraulic assistance.
And the aircraft getting a bit uncomfortable in the right.
From a qualitative point of view in the back here, as you failed it, it was quite a lurch. I mean, imagine you're a royal person and you're sitting in the back, not really know what's going on, with a gin and tonic in your hand, and suddenly that happens.
The exercise is typical. The students are now evaluating aircraft and flying as test pilots, all very different from their past squadron experience.
What we're now looking at is areas of grey where we're asking these pilots to change their philosophies, that we're not asking them to do a good job with the aircraft, which they had to do when they were a squadron pilot. We're asking them now to almost forget about that aspect of their training, to unlearn that. Now they have to say, look at the pure aircraft, look at the way it handles, the way it performs, and ask themselves, can it do the job? Not can they, the test pilot, do the job, but can the aircraft do the job? We put the students onto basic aircraft to take away the learning process of learning to fly the airplane. Because it's a short course, we can't give them 3 or 4 hours practice on every aircraft they fly. If they go onto an aircraft like the Chipmunk, then they can get into it, and within a few minutes they can fly the airplane, and then that can become the second nature, and they get on with actually testing it as opposed to just learning to fly it.
The exercise is called pilot's assessment. For the first time, students are testing a complete aircraft. Robin Tiedemann, away from Boscombe Down, is checking an Army Chipmunk at Middle Wallop. It is a typical trainer of the 1950s. But Robin is to look at its handling in terms of today's requirements.
I'll give him 1 hour just to assess its handling qualities.
What will you be doing?
Taking it through a typical student profile and assessing its qualities in terms of handling primarily to see how it behaves. As well as that, we're looking at any areas which might prejudice the safe operation of the airplane.
Although the Army still use the Chipmunk as a trainer, it is a rarity these days because it has a tail-wheel undercarriage. Robin Tiedemann is expected to fly it without further conversion training, though it is very different from the Victor tankers he used to fly. Indeed, very few RAF pilots have extensive experience of piston-engined aircraft. Robin climbs the Chipmunk to 3,000 feet to begin his handling tests. At Boscombe Down, he has been trained to set aside his considerable experience and to put himself in the position of a nervous student on his first solo. A steep 360-degree turn. Robin notes the precision and harmonization of the controls, the hallmark of a good basic trainer. No vices here. The weather is not ideal, but just good enough for a test spin. No vices here either. From a dated aircraft to one of the latest. Harry Fail is at Old Sarum, one of the world's earliest airfields, to put a prototype Optica through its paces. Writing forms an indispensable part of all test flying. Harry begins by plotting the Optica's turning circle. The unconventional opticas are seen as an inexpensive helicopter substitute. However, James Giles' brief is held against the background of a recent fatal crash.
Okay, part of this test will also be the accelerated stalls.
Yes.
Because being on the scene again, the pilot might be in a tight turn, looking outside the cockpit, not concentrating on his instruments. And I want to check out what information he gets from the aircraft behavior that he's approaching the stall.
You're obviously aware there has been an accident.
Yeah.
Obviously, we don't know why at the moment, but it was in that sort of maneuver, and that's the sort of thing you need to check on aircraft like this. Bear in mind what it's going to be used for. So, and presumably this will go on to the accelerated stall.
Yes, accelerated stall comes a little bit later.
Harry has prepared the cards for each phase of his test flight. On these, he will jot down the data for his Optica report.
I will look there. If the pilot is able to put in a certain amount of angle of bank and can leave the controls free, because he might have to take pictures,
certainly,
you know, or just looking around doing something else with his hands.
Exactly. In other words, he's looking out, he's looking at the ground. What is the aircraft doing when he's not in a closed loop situation? First thing is flying off grass. Have you actually flown off grass before? Right.
It will be the first time.
Right.
Harry Fail, a Luftwaffe F-4 Phantom pilot, thoroughly evaluates this unusual aircraft. On the test pilot's course, simply flying an aircraft, however well, is not sufficient. The students have to assess the aircraft's characteristics, both good and bad, and then write a clear and concise report. The third light aircraft to be tested is the prototype Trago Mills, here landing at Boscombe Down, to be flown by Dave Southwood, guided by his tutor, Tim Allen.
You are assessing the aircraft from the very moment you start out walking towards it. Virtually when you start looking at it, you start your assessing of it. So from every single aspect of the aircraft, everything you do with it, everything you touch, everything you handle, everything to do with it, you're assessing it. Right. Bearing in mind throughout that it's relating to the role of the aircraft. I know it's a prototype aircraft and it's a civilian aircraft, but we are assessing it for the role of primary trainer, like the chipmunk or the bulldog.
Sure, yes.
Okay, let's have a look at your cards. Stalling is a very important aspect for primary trainer, so have a careful look at it. But the last time you did stalling, you had, well, 2 flights, 1 hour each.
Yes.
Here you've got about 2 minutes.
Yes.
So there's the change there. You've got to get it done quickly and efficiently. It's obviously got to do aerobatics nicely, and I see you're going to get your stick force per G off that. That's a good idea. Also look at the performance of the aircraft. I know this is a handling assessment, but at every stage try and wind in the performance and the fuel usage and so on. So here, on the overshoot, with the full flap down as for landing, the climb may be rather poor. Yes. So have a look at the performance aspect of that. It is primarily a handling assessment.
Yes.
But your feelings are the most important thing, and the numbers which you take will back up any deficiencies which you found. It is, after all, a new prototype aircraft. It's the only one in the world.
Dave is to be accompanied by Air Marshal Jeff Cairns, himself a retired RAF test pilot and former commandant of Boscombe Down. He is now on the other side of the fence, for he is the director of the company which built the aircraft. He will act as Dave's flight observer.
You want to adjust the rudder pedals first before you do anything else, before you strap it. Right, at the bottom you've got a clock and ammeter suction for the air digesters. You've got the VOR indicator, AD.
This small trainer is very different from the buccaneers Dave is used to. But as a test pilot, he will be expected to be able to fly any aircraft. This pilot's assessment, like the others, has to be completed in 1 hour. Not really long enough to test a brand new aeroplane. To help with his report, Dave has the usual voice recorder.
Going Washington 3, 2, 1, now. And that's a second to the right. Look up. We just full left runner. And it's around 50 pounds forward. Aileron about 10 millimetres. And about 10 pounds forward. And 20 degrees aileron bait. And releasing.
A careful lookout and a spin. For Dave will need to test the trainer's ability to recover.
Losing and reach, that's 1 turn, 2 turns, stabilise in front of high rated turns, 3 turns, that's 4.5, 4 turns, 5, right rudder, still coming forward.
Pilot's assessment, like all flights, has its paperwork.
And I actually wrote about 75 sides of writing, I think, after just 1 hour's worth of flying. So nowadays, flying can never be fun anymore. You tend to go out there, and the first thing you do is get in the aircraft and think, don't like the cockpit, feel the view's not too hot, controls are a bit hard, and so you're forever analysing everything you look at.
James Giles has Harry's Optica report. It represents some 20 hours of writing for an hour of flying.
Harry, that was a very good report. Thanks very much. As you appreciate, that was actually a pre-production aircraft. It was a prototype, and there were a couple of things that you probably weren't aware of. One was that the port wing was about 2 degrees out of alignment, and it was misrigged, which I'm sure accounts for some of the facts you've come up with on the spiral stability, and indeed the stall. And the other one was the elevator effectiveness, which you mentioned into the ground, and they are actually working on that at the moment, and certainly the production model should have a new elevator.
In ground school, the 3-man test team are about to make their presentation of the Jaguar low-level exercise. They have found writing the presentation hard work in the limited time available. Only 30 minutes are allowed for its delivery, and the expert audience will have to be convinced of the students' recommendations.
The principal weapon aiming modes assessed were CCIP with radalt ranging, target of opportunity, planned, tracked PLF and regress PLF, attacks all in both barrow and radalt ranging.
All the technical data is there, but in addition, the knowledgeable audience is looking for style in presentation. This is vital if test pilots are to be able to convince civil servants and aircraft manufacturers, to say nothing of air marshals and admirals, of their findings.
A likely condition in the event of
It doesn't matter how good the tests were or how skilled the test pilots. If the presentation fails, they have failed the whole exercise.
This detracted from the pilot's ability to look at the targets and to maintain safe terrain clearance. That concludes my weapon aiming assessment. I'll now call upon Flight Lieutenant Nick Coulson to summarise our assessment of the Jaguar Navwest.
Thank you, Liz. In summary, we found the Navwest to be a reasonable aid overall. However, there was a lot of room for improvement. Specifically, the aircraft must not be released to the low-level bombing role.
The staff make their notes for the critique which will follow. One point is already clear. The VA's visual aids are certainly not flowing as they should.
Okay, this is the actual position of the pilot's eyes when he sits in the cockpit. You can see on this slide that the PCP underneath the head-up display is almost completely hidden. This is due to the fact that pilots are now enabled, in order to see the head-up display correctly,
There is some sympathy for the French student, Serge Aubert. It is not easy to lecture to experts in a language not your own, and that will be taken into consideration when the presentation is marked.
and satisfactory, and we recommend that these main switches should be positioned in a pilot's field of view.
There are a number of further recommendations included in the report. Thank you for your attention, gentlemen. That concludes our presentation.
The three students withdraw to allow the staff to discuss and mark their presentation. The marks are out of 10.
Right, start from the top. The timing, I made about 2 minutes over, so we'll give them an 8 for that. The VAs, relevance and quality, what do we think about those?
I thought some of them were a bit fast the way they were put up, and also when at one point when Nick was trying to point out switches, he was waving the pen over. I wasn't sure whether he knew where they were either. So I think they could have made better use of their VAs.
Yeah. They had most of the things there. They had most of the conclusions right, though I think they overstated some.
On the weapons aiming side, it didn't come over clearly. Likewise, on the nav side, I thought, for example, the nav system accuracy was awfully poor slide.
What did I take on that one? About 6 again?
Well, difficult. I'm going to say 5 myself. I don't think that they display to me an overall knowledge of the system, taking it across the whole of the group. Serge was very quiet. I could hardly hear him, and then it went off at a high rate. Was difficult to understand sometimes. And Les actually read his script, which is what I would expect, but he didn't know his script, which meant there was no eye contact with the audience, and it was fortunate that we could take our eyes away from him and look at the slides. Otherwise, you know, we could have had somebody in the corner reading it from a book, really.
They didn't put things into context. They didn't explain why. They'd suddenly come up with a conclusion, and there was no lead-in, no build-up to it.
I think mine's a generous 5 on that.
Yeah, well, I certainly have a 5 for that.
Yes.
The B Syndicate did pass, just. But how did they feel about the low marking of their presentation?
Well, that presentation, in fact, was quite rushed. We only really had 3 days when the three of us could get together. And those days were fairly busy days. We were already flying anyway. So I think you could say that we actually prepared that presentation on about 2 or 3 nights, which is part of the reason why it was a bit of a shambles, and things weren't actually as well coordinated as they should have been.
A Chinook lands at Boscombe Down for an exercise with a difference.
Yeah, whether we need it or not, we do it every year. Often it gets cancelled due to weather, and we have a very narrow bracket because if we don't get it in today, we'll probably have to cancel because we can't afford the extra time. But I think the guys enjoy it, so we'll see what happens.
This is my first time in the sea.
I'd rather do that than land on land for the first time.
You jumped before, sir? Yes. About 13 times.
Do we have to do it? Is there any way
Bit of fun. Why not? It's part of the course.
Anybody change their mind in the aircraft?
Shall we say they will be guided out of the aircraft and assisted?
It is the annual parachute jump into Studland Bay. The jumps are made from 1,000 feet, at which height the Chinook is only just clear of cloud. The water was reported as freezing. The jump is voluntary, but nearly all the test pilot students and staff took part. Royal Marines hauled the sodden officers aboard the rescue boats without ceremony.
Ross, can you spread the bags out, James? Is there a better way in than that?
No, it's always a door.
How was it?
Oh, it's tremendous. It's the sort of thing every BBC filmman should do. Oh, not again.
Did you enjoy it?
Excellent. Super.
What's the best thing about it?
All of it.
Being sick in the airplane.
Yeah, being sick on the way down, I think, was the best bit.
Good game.
Did you enjoy it?
Yeah, marvellous.
Would you do it again?
Yeah. Who's got the beer?
No, where are the beers?
Who's got the...
Survival kit.
What do you say?
Just over the edge, that was all there was to it, really.
I'll be over the edge.
What HQR do you assign to that one?
I always say it's got negative NV.
Dave Southwood, ever the test pilot, awards the parachute handling marks.
Control, not bad.
His next flight will be very different, for he and the other students will be test flying modern military aircraft that they have never before flown.
Navy 304, this is Toscan radar. What level will you fly?
As the summer ends, the 44th Test Pilots course is also ending. For 8 months, the students have flown different types of aircraft on arduous exercises. Some beyond normal RAF limits, some to the very boundaries of the aircraft's performance. But it's not all flying. There are 250 hours of lectures.
Of an aircraft, then from the equation, if we make a certain assumption...
And even a night school.
On the glide path, approaching position height, on centre line, on the glide path, passing position height, half mile from touch, down, clear to roll, 170, 10 knots, when coming to step 2, dot and out.
The night exercise is one of the last of 130 hours each student flies at the Boscombe Downs School.
Trim stars responding. Pass at 20. Stars responding. That's good. Rotate.
A significant stage of the students' progress is when they bring together all their newfound skills to test fly a light aircraft. This is a preparation for the preview, the student pilots' finals, to test fly a frontline jet they have never flown before. The aircraft to be previewed are revealed. An F-4 Phantom at Coningsby, swing-wing Tornadoes at Honington, Buccaneers flying from Lossiemouth, and to America to test fly the F-18 Hornet and the S-3 Viking. The helicopter students will fly the controversial Black Hawk and the big twin-rotor Chinook. First, the staff meet to match pilots and aircraft.
We're obviously not going to put them in aircraft they've flown before, and we'll try and stick towards role compatibility, which I think might be a bit tricky this year. I think in this Tornado F4 Buccaneer.
Right. So let's look at Tornado then.
Well, I'm tempted to suggest that we put Tom Coulter on that. My rationale for that really is that the Tornado being a swing-wing airplane and him being an F-14 pilot, we might be able to get some good read across on the Tornado.
We've got Steve Moore.
Yeah. Yes, they've made a good team
there. Dave Southwood, he's
pretty strong, isn't he?
He's very strong. He's doing well on the course, and it'd be nice to...
I think we get as the F-18, it's the first time we've done the F-18. I think it might be a nice thing to put him on. Perhaps Harry Fail might be a good man to go in there.
Well, let's just put that along the side at the moment.
Yes, they've made a good team
there.
As long as we can keep them out of the pub, I think that'd be...
Yeah. Well, to keep his chitter out of the pub as well over in the State. Who's doing that then?
No names, yeah.
On the only reasonably heavy airplane that we've got this year, the S3 Viking, so they sort themselves out quite easily. Robin Tidyman and Nick Coulson.
Yeah, that'll work out well.
Well, the next one to look at is Jim Ludford.
Well, I think I'd like to see him in the Buccaneer. I think he could do a good job because he's in the front there on his own.
Yes, we've got to fly there.
He's a reliable guy. I think we'd...
Fly the Buccaneer as captain.
Yeah.
Quite happy to see him in there. Yeah. So we've got Sergio Bear. Now, his background is also air defence.
Yeah,
he's done some air defence. The Mirage and the F1.
Well, he'd make a good match-up on the F4 then, because he's not likely to have flown it. Not likely to fly it again back in France.
He certainly won't have flown it.
Yeah. So he can actually, if we put Les in there, Les being a Harrier background man, Serge will provide the air defence side of that for the preview. So that would be a nice balance, I think.
Who have we got left then? We've got Mirko.
Yeah.
Now, Mirko,
He's a big chap. We've got to watch what we put him in.
I'd be tempted to put him in the Buccaneer to give him a change. He's had a hard year this year because his size. Two aircraft he hasn't been able to fly. He would definitely fit in the Buccaneer.
We try to give them aircraft that they have not flown before. And we try to give them an aircraft which they will have some knowledge of, either in its role or its configuration, something that they have something to hang on to. But they will certainly not have flown the aircraft before. A very large portion of our assessment of the students at the end of the course is based upon this exercise, both on the way they conduct themselves during the preview and also in what their report is like and what their final presentation, their verbal presentation is like.
The American Tom Colzer and the New Zealander Steve Moore on the right are at Honington, the Tornado base. Neither man has even examined the formidable swing-wing aircraft before, and yet they have only 10 hours of flying time for the entire project. They begin work at once.
Free taxi runway 09 at QFE 1025.
Each preview syndicate has a supervising tutor. The CO of the Boscombe Downs School, Wing Commander John Bolton, is at Honington.
Well, my role is initially to supervise them from the test flying point of view, to make sure that they are not going outside their brief, and also to get some experience on the aircraft myself, so that I can assess the report.
From Honington to Odium, where Fleet Air Arm student Al Howden is leading a syndicate to preview the Chinook helicopter.
And we'll transition away and transition out to the area and look at the single engine flying. Happy with that?
The other members of the syndicate are the Canadian Mike Micklejohn and JT from Singapore.
Okay. Yeah.
Like the fixed wing students, none of these young helicopter pilots has flown the test aircraft before. The Boscombe Down trio will test the helicopter both at high altitude down to the lowest height permitted.
If you notice
JT records on video the instrument readings for later analysis.
let me know. Pull that to launch will go down on the left-hand side.
Now Mike Micklejohn is coming down to minimum height. In battle, supply helicopters like the Chinook have to operate as low as possible. The syndicate are briefed to assume it's an untried aircraft and are testing its controllability at very low level, 50 feet. This is called nap of the earth flying.
There we go, that's fine. I don't know, we would cruise at 50 feet, 135. Yeah. Just through the gap, 4:30, I'm slightly in front of the nose. Hold it nicely, thank you. Got the wires. Yeah. Little wires, you got them? Yes. Good. Okay, you're getting close to base there now. If you just keep it around about 100 feet, that would do nicely. Okay. Follow through the gap now. I was just going to give him some handling by taking the AFCS off on him, actually. How do you feel now? I'm doing a sloping ground landing.
The Chinook is positioned for a landing on sloping ground, a difficult maneuver for a big helicopter, but one which might well have to be made under active service conditions. The syndicate have to assess all aspects of the Chinook's fly. Moreover, as all the tests have to be completed in 10 hours, there is no time to waste.
Let's go home.
The last airworthy Lancaster in its hangar at Coningsby. Les Evans, waiting to fly the Phantom for his preview, takes a look at this warplane of the past. One of the bomber's 4 Merlin engines is being serviced, as during the war, by a young woman. For a fighter pilot like Les, there is only one aircraft to be approached with reverence, a Spitfire, one of the Battle of Britain memorial flight.
I'd give a right arm to fly this, it really would. It's a tremendous airplane. Very different handling to a modern fast jet. Directional control will be somewhat reduced from a fast jet. The prop wash effects will be quite high. You'd expect some adverse yaw from the ailerons. I wouldn't mind betting the control force is slightly high, but I don't know. It's back to the F4 again.
At the moment, the Phantom is being flown by the other half of the Coningsby syndicate, the French student Sir Gilbert. He is trying to come to grips with an airborne VC-10 tanker to refuel. Refueling forms a vital part of present-day defence strategy, and the capability of the Phantom has to be assessed as part of the preview. Voila. As Serge refuels, Les is briefing his airborne minder, Jack Dowling, an experienced Phantom pilot.
Looking at the stick forces per G, as I said, and the lift boundaries.
His tutor, Tim Allen, is supervising the preview.
Up to 1.3.
Okay.
Can I make an interjection here? Jack, it's your aeroplane, you're the expert on it.
Yeah.
But knowing wind-up turns, I can see that at the higher speeds and the higher G levels, the aircraft is going to end up extremely nose low. So it becomes a major safety consideration. Yeah. So it's up to you, I think, to tell Les when to call
certainly
quits.
if we're supersonic getting more than 40 degrees nose down, you're at 5,000 feet, you need 8,000 feet to recover.
Yes,
so we'll have to see how it's going and how deep the nose is going on.
Yeah.
Serge lands. He and Les are working as a team, but they fly the aircraft individually.
This exercise in the Phantom is actually extremely good value from my point of view. You regard the whole concept of flying an airplane much differently. It's not actually using it for its job, but you just fly an airplane and naturally seem to assess it as you're flying it. I'm certainly finding that flying, for example, the Phantom as I'm doing, with very little knowledge of it, it's surprisingly easy to fly the airplane, and you naturally, after the course does the right thing, you start to actually assess the airplane as you're flying it, without even thinking about it. So your approach to flying has changed. Oh, yes, yes.
As most of the flying from Coningsby is over the North Sea, the air crews wear special survival clothing. It appears cumbersome. How quickly can it be got on?
If you have to, you can do it in about a minute. You can get the whole lot on. Because when you're holding alert, you know, you jump out of bed at 5 o'clock in the morning, you've got to get it all on in this part of the country. So we'll go and pick up all the details, certainly the latest met when we outbrief. Dave, is our aircraft ready yet? Uniform. We're Foxtrot 4 Victor. Call sign up there is 32.
Les, what's the gauge for?
Well, this is a force gauge which we use for seeing what the stick forces are. As you see, if I squeeze it, you get a reading on this gauge, and the little black needle stays at the maximum that we've actually applied. And you can just reset that in the air. And primarily we use it for holding against the control column, and then we can measure the stick pull force that we're applying when we hold against the side of the column. It aids us in actually deciding or determining how stable the airplane is. Part of the stability of the airplane is shown by the forces that you need to apply to the stick. So we take various heights and speeds, you just note the forces required to change attitude and to change roll.
Les eases his Phantom out of its hardened hangar and taxis to line up on the Coningsby runway. On this part of the preview, Les is sampling the Phantom's handling at low speed. Next, it's stability. The Phantom is, of course, an American aircraft, and it is in America that some of the school's previews are to be flown. The Naval Air Test Center at Patuxent River, Maryland. the American equivalent of Boscombe Down, though with some national differences. The centre includes a test pilot school modelled on the original at Boscombe Down, but 5 times larger. There are 3 Boscombe Down syndicates previewing at Patuxent River. Harry Fail, who flew Phantoms in Germany, is to present his preview partnered by Dave Southwood, the Buccaneer pilot.
Because then you'll get...
They're preparing to test fly the exciting Hornet fighter.
The F-18 Hornet's the latest US Navy aeroplane in service, used as a strike attack aeroplane and also for air defense. It's quite hard coming out here because the amount of information we had on the aeroplane before we left the UK was fairly limited, so that we really got a lot of the information, the manuals, when we arrived here on the Monday to then start flying on the Wednesday. So we had to do a lot of work when we first arrived just to get familiar with the basic system so we could fly the aeroplane. We had to take an exam on the basic systems of the aeroplane so that we could fly it from the front seat. The schools in many ways have a lot of features in common, but the courses here are much larger and they're more predominantly US Navy pilots and engineers and backseat crew on the school as well, whereas Boscombe we train virtually all pilots. It's been a very interesting aeroplane to fly because this particular airframe is a fairly early development aeroplane. It was from about halfway through the development program. So from the handling qualities side, there have been a lot of things we've found on it which have subsequently been corrected on the aeroplanes that are in service with the fleet. So as well as before on the course, we've always flown aeroplanes really in the production service standard. This is an aeroplane to a pre-production standard. So there's a lot of interesting features about it that we have found. Quality side, the turn performance, manoeuvring of it's excellent, and the systems on it are very modern, state-of-the-art systems, which again we haven't actually had a chance to look at on any aeroplane on the school and on the course so far.
Links between the Empire Test Pilots School and that of the American Navy are close, though there is friendly rivalry. Rear Admiral Ned Hogan.
I'm a graduate of the Empire Test Pilot School, and I came back from England to Patuxent River. And again, I tend to have biases. I always thought the Empire Test Pilot School was the best school then because I'm the graduate. Now that I'm in charge of the Navy School, I think it's the best. So the quality of the individuals are almost the same. The young men and women that get involved in it are more or less cut out of the same cut of cloth. They're high achievers, they're aggressive kind of people, they're highly active, they have a professional approach to doing business. So basically, those personality traits and characteristics are awfully similar. And the products of both schools, I think, are close to equal.
Will Nick Coulson and Robin Tiedemann be equal to testing the Viking?
It's a 2.5-hour trip this afternoon, and so far we've spent, both Robin and myself, we spent about, Sunday yesterday, we spent from 9 o'clock in the morning till 5 o'clock in the afternoon. Plus, what, 2 hours this morning so far. So there's a fair amount of preparation goes into each flight. And that's just basic preparation for the flight. We've obviously planned the sortie profiles and things before that as well. So there's a lot of preparation goes into it, yeah.
His partner, Robin Tiedemann.
Well, on this sortie today, we're going to have, first of all, a qualitative look at the aeroplane, just to see if it has any bad vices. And the major part of it today will be just gathering data in terms of its longitudinal stability, and then some asymmetric work, and finally the last half an hour we'll spend in the circuit pattern, just looking at the various modes of landing the aeroplane.
The Viking is a carrier-borne anti-submarine aircraft, which has no equivalent in the British forces. To fit into aircraft carrier hangars, the Viking's tail and wings have to fold. The Viking must be one of the largest aircraft to have folding wings. Interestingly, the electronics carried are reported to cost more than the aircraft itself. ETPS students fly at Patuxent River on a no-cost exchange basis. In return, some American Navy students do their previews at Boscombe Down. The Viking takes off for the first of its testing flights. If it is a little-known aircraft in Europe, the same cannot be said of the helicopter about to be flown by Bob Horton.
This is a UH-60 Black Hawk, which was built for the US Army. It was about 1970s design, but of course it's their most modern battlefield helicopter, really. It features a lot of quite unique design features. For instance, it's absolutely covered in armour plating. You've got all this sort of stuff to protect the pilots. It's also been designed to be air transportable in the back of a Hercules transport craft, which is why it's got this very squat appearance to it. It's also got a couple of General Electric T700 engines up there, which give it an enormous amount of power. The tail rotor itself is actually canted at about 20 degrees from the vertical, and that's because the whole aircraft, once they'd built it, it had a very far-off CFG, centre of gravity, and had a lot of problems trying to hover it and what have you in forward flight. And so some bright spark said, well, why not just tilt the tail rotor so that it's actually producing an upward thrust moment as well as a lateral moment. And so it now provides about 2.5% of the total lift force in the hover.
The previews are in reality part of the final examinations of the test pilot's course. One of several unique features of the Black Hawk is the stabulator, an all-moving tail surface which, it is claimed, greatly aids stability, a claim Bob will be testing. As Bob begins his first test flight, Dave Southwood brings the Hornet into lab. The other half of his syndicate, Harry Fail, is checking the details of his first sortie with his American observer.
On the speed, AOA, distance.
The testing is divided between the members of the syndicate, each investigating different aspects of the aircraft's performance.
All right. Okay, if you turn over to page number 2, I mainly talk on my tape. It's going to be in German language also.
Have you got, you're going to use the HUD camera?
Yes, I plan on.
Do you know how to use that?
No, not quite.
The flight observer, himself a test pilot, has two roles. First, to help in gathering data for Harry, and secondly, to make sure the aircraft is brought back in one piece. Harry's first Hornet flight begins. The aircraft carries a price tag of $17 million per copy, so it is a heavy responsibility for all concerned. Most of the data they gather is about the Hornet's performance, and that is highly classified. But it is known to have the very latest computerized aids to flying. At the end of his first 2-hour flight, Harry Fail was certainly very much impressed.
Fantastic. Really. It's amazing, you know. F-18 is really new generation. To what I was used before and what I flew before, it's like Star Wars almost. Well, I guess it's going to be a sleepless night. I have to write about it, what I found out.
For all the students, there is little time for sleep. For when they return to Boscombe Down, they will have to make that full presentation of their findings, the final test. The audio notes made in the air have to be transcribed and carefully analyzed.
What's how happy we're going to make the land? And 5-8, Roger. Crash elevation 600.
As Dave Southwood and the other students work on their reports in America, in Scotland, another syndicate is being briefed for their preview of the Buccaneer.
So you're going straight into an aircraft which has no instructor in the back seat. There's a navigator in the back. You'll be putting him into situations which he's probably never been in before. So moral is obviously be careful, plan everything ahead, know what you're going to do, and brief the guy in the back before you do it.
And basically what I'm aiming to do is a very gradually...
Now, there are no dual-controlled Buccaneers. which might account for Jim Ludford's observer's somewhat thoughtful expression.
Position when it's stabilised at that G, at that speed.
For Mirko Zuliani, this is his first Buccaneers solo. How did he feel about it?
A little bit nervous, but I think that the preparation that we had during the course is the right preparation for the right approach to a new aircraft to fly. And as I said, Jim, the experience to jump from one aircraft to another aircraft.
Mirko was chosen for the Buccaneer partly because it was one of the few aircraft into which the Italian giant could fit. Most of the RAF's Buccaneers are ex-Royal Navy. Having been designed for deck landings, they are immensely strong.
Turn left now. That's nice. And roll out there. Just aim to the right of Lossy Town.
Okay. This is about the best you're really. You're feeling immediately power and air brakes.
Yeah, you should have about half air brake now and 87%.
There's a coming alpha and increase the power.
90% power.
Stop and 90% reduce.
Good.
And the old 180. Okay, I go for traffic.
I'm sorry, stud 2 I want.
Stud 2 you would want.
Thank you very much.
Because of their training, the ETPS students seem to a man to have acquired considerable confidence and experience in a remarkably short time.
We're looking for about plus 15 knots at this stage. Okay. So we're talking about 156 knots.
Jim Ludford.
One thing the course has done is tune us into getting from one aeroplane and becoming fairly familiar, or adequately familiar, with another aeroplane to go off and do the sort of tests we've got to do with it. And of course we creep up on the limits. Let's rather go straight to them, so just take a fairly gentle approach to it all. Perhaps we're flying it more as an aeroplane than the guys on the squadron do. They do with it what they need to do, but we've got to go out and find the corners of the little box within which you can operate it. It's fairly obvious to a lot of people that there are deficiencies with all aeroplanes. You can, just by talking in bars and crew rooms over the years, you get to feel that. The handling of the aeroplane is probably going to be quite adequate for the job, but there could be some aspects, of course, that we haven't heard about, or which we need to look at a bit more closely.
As Jim taxis out, Mirko returns for a touch and go.
Fast. Okay. Just keep it going down. Okay. I'll tell you when to put the power on.
The touch is fine, but it's no go.
Bring the nose wheel off. And fly away. Power is good. A little bit of power. Power.
For Mirko unintentionally shuts down an engine.
Do not put up the undercarriage.
Okay, I go on the right?
Yes.
Apart from that little local difficulty, the rest of the flight went very well. And as Mirko graphically explains to his observer, he is delighted to have discovered a flaw in the Buccaneer controls on the very first flight.
Yeah, 16,000 feet go down.
The preview flying over, the really serious work for all the syndicates, the report writing. It is of the greatest importance, for if done badly, it could lead to total failure. The finished reports are impressive documents.
Preview has been over for now 10 days, and we've just received these submissions. This is the S3 Viking, and this is the F-18 Hornet, the two previews that were carried out in the USA. You can see it's a fairly weighty tome, and for 10 days writing, there is an awful lot in there. And in fact, I think at this stage, the chaps are moving so quickly that even the tutors would find it very difficult to produce something the equal quality and volume and the time.
The long hours of writing over, next the final hurdle, the verbal presentation. All that now remains between them and the coveted title, Test Pilot. The previews, the final flying of the test pilot's course, have ended. All that now remains is graduation.
Perhaps I arrived here with a little bit of apprehension about doing the job of a test pilot, and I've certainly got enough confidence now to go ahead and give that a go.
I've flown 19 types on the course in about 170 hours, and there's nowhere else that you could get that sort of flying experience apart from at a test pilot school. So yeah, it's been outstanding.
And they told me it's going to be a lot of work, sleepless nights, but you know, they didn't tell me the truth. This is awful lot of work over here, you know.
For the past 2 weeks, the student test pilots, divided into syndicates, have been testing a wide range of operational aircraft, none of which they have flown before. Each syndicate was allotted 10 hours of flying time to probe the limits of the aircraft as test pilots. The flying was from bases as far apart as Lossiemouth in Scotland, Odium in Hampshire, and Patuxent River, Maryland, USA. One of the pilots testing an American aircraft was the senior student, Robin Tidyman. How has the course changed him from a squadron to a test pilot?
Well, for someone who isn't yet a test pilot, we're only about 9/10 of the way through the course. I suppose the difference is that on the squadrons, you're just given a task to do, and despite the aeroplane, you have to go out and do it. And from everything that we've seen here, perhaps our job is to now go out and do the same tasks, but this time try to find out what the problems are with the aeroplane and try to make sure those problems perhaps are not there in the future.
From the scattered bases, the students return to the test pilot school at Boscombe Down in Wiltshire. The previews may be over, but there are still 2 heights to be scaled. The first, writing up the reports in just 10 working days, which means many working nights, to produce what amounts to a complete aircraft manual. To the last, the pressure is maintained, as it will be when the students are working test pilots. Then all reports will be urgent.
I can't expose the report to you, as you know, because it is restricted. You will see, although it is full of words and not just pictures, and it's all written by the chaps in hard work, perhaps, and the detail to which they actually construct. Perhaps if we go down to one of the annex, there's in here, I can probably show you, even to things like drawings of the cockpit that they've put together to make it a readable volume. I don't think I need to say any more, really. It is absolutely packed full of facts, and to be able to produce that in 10 working days, I feel, is quite a feat.
If I'm going to work this hard again, I have to earn a lot more money to do it, you know.
It has been extremely hard work. A lot of good stuff in there, but I'll never do a course like this again.
I think I can safely say I'm never going to work this hard again, because if I do, I shall die.
The course is difficult, and if a man doesn't meet the requirements, he wouldn't pass it. It's not fair to him to put him out into to fly in situations which he might not be capable of handling, and it's not fair to our customers either to do this. So he must reach the standard. But having said that, as I said, the selection procedure does ensure that we do get good people, and in general, they do pass. And people come here very worried about the level of the course. I indeed was very worried about the level. My academic qualifications were low to come on the course. However, I came on it, I passed it, and I was taught what I needed.
Although the students' families live in married quarters just outside the base, one of the very few occasions which included the wives was the annual cricket match. But it is not only security which separates families.
All the wives have been complaining because the fellas will finish work here about 5 o'clock and go home, and the first thing they'll do is walk in through the door, say, "Hello, dear," straight upstairs to the bedroom or the study or whatever, and start writing, because there's so much to do.
Although we disappear off to work at 8:30 in the morning and normally home by 6 in the evening, you get home and then you probably, as I say, work till midnight or later with a quick half-hour break for dinner, so that the wives actually see very little. And the same applies at weekends. That there's sometimes some weekends where I just had to work all through the weekends as well.
I think for us it's not such a bad deal. Well, we soon slot into this way of life. You sort of work all day, go home, eat and work all evening. I think it's worse for the wife and the kids because all of a sudden Dad is not around, go and play football, that sort of thing, and they've really got not much else to do.
Despite their discontent, the only wife to speak was Madame Aubert, and her criticism was mild.
It's a very hard year for my husband and also for all the family, and all the families here. I am very happy for Serge because he wants to be test pilot since a long time, and I am very happy that he became test pilot.
But Serge is not yet a test pilot, for he and Les, having submitted their report, now prepare for the final hurdle, which is in many ways the most daunting of all, the formal presentation to an expert audience.
There's a lot of difference between writing reams of facts and words and then getting the facts across to an audience in 30 minutes. And it's a different technique, which is why we do a presentation, so they can see both ends of their art, both communication and written work.
For their presentation, Les and Serge tested the Phantom at Coningsby. That was to prove to be the easy bit. Now at Boscombe Down in the secure theatre, the critical audience awaits to hear the presentation. Les is anxious, for he and Serge had a less than successful reception to their previous presentation earlier in the course. They are fervently hoping that this far more important occasion will be rather better received.
Good morning, sir. Ladies and gentlemen. Following a Ministry of Defence requirement for new air defence aircraft, a team from the A&AE Boscombe Down was tasked to perform a preview assessment of the Phantom FGR Mark II. The team comprised Commandant Serge Aubert of the French Air Force and myself, Squadron Leader Les Evans. We were to assess the aircraft for its suitability as an all-weather air defence aircraft, as an interceptor and air superiority fighter. During this presentation, which is classified restricted, we will look at the performance of the aircraft and of its weapon systems.
The Phantom presentation has begun well. The visual aids are being cued slickly, and there is no doubt that Les and Serge have secured the full attention of their audience, in contrast to their earlier effort, which Les himself described as a shambles. The quality of the presentation could, even at this late stage, affect their successful completion of the course. They are well aware that every fact, every figure is being weighed and considered.
Well, we're looking from two aspects, what we call quantitative and qualitative data. One is just straight numbers, obviously, and anybody can collect numbers. We could probably send a monkey to collect the numbers. However, what we need is qualitative impressions and from the chap in the cockpit, the test pilot, such that he can see whether things are natural to do, the reactions of the aircraft, so we can build up a picture, a true picture. After all, a man will be flying the airplane, and therefore we need a skilled observer to tell us at an early stage if there are any problem areas.
The field of view from the front cockpit was measured on the ground and assessed in the air, both in close formation and in combat.
A fighter pilot's field of view is clearly vital. It could well form a problem area to be picked up by a test pilot.
Angle of attack gauge and angle of attack donut took up prime space, and arcs of 6 degrees width to the left and 10 degrees width to the right were obscured.
Many of those present have a detailed knowledge of the Phantom and its faults, but test pilots often have to argue a case to convince a skeptical audience who have no first-hand experience of the test aircraft.
He's got to be able to convince people that his results are facts, that he is right, and we're talking about large sums of money, of course, in some cases, to modify aircraft that are already existing.
That concludes our presentation. I'll invite questions from the floor, which I'd ask you to direct through me.
In Defence Standard 00970, there's a specification criteria by which you can define how satisfactory or unsatisfactory the SPO is. Yeah. Can you say why you didn't use those criteria to reinforce your recommendations?
Yes, certainly. We looked, for those who don't know, the criteria lays down a chart against which a plot of the natural SPO frequencies against the N-alpha, the relationship between applied G and incidence.
The questions are highly technical and are deliberately framed to probe the depth of the student's understanding of the test aircraft. The answers will be assessed and marked as part of the presentation as a whole.
7 degrees per unit, but that was purely off one document which really only referred to one particular speed.
Your reason for using rudder was only to increase the roll rate and no other reason?
Yes, only to roll the aircraft.
So what would happen then to a pilot that reached those angle attack above those 15 units?
The question and answers continued for some time. But at last, to the relief of Serge and Les, it was all over. In the audience were the two instructors from Coningsby. They have more experience of the Phantom than anyone in the room.
There are some obvious deficiencies in it, which most people would find, but certainly with the work they've done on the 2 weeks they were there, they've highlighted certainly the other areas that even people, I think, that are just coming onto the aircraft don't realise that you have problems with it. So, you know, I was quite impressed, in fact, what they pick up in the short time they're there.
Came up with terms while we were flying, which I just couldn't believe, about short-term loops and things like this, and now I understand what they meant. So, but they certainly picked up a lot more very, very quickly than people who've been flying it for 1,000 hours. I was quite surprised.
How do you feel? Very relieved, actually. It's a tremendous feeling to have finished, actually got it all behind us.
I feel heureux. Happy.
For the second syndicate, it is yet to be. The Chinook helicopter presentation by 3 of the rotary wing students is next, and its low-level performance will form a major part of the presentation.
Good morning, gentlemen. Welcome to our preview presentation on the Chinook helicopter. For those of you who don't know me, my name is Lieutenant Alan Howden. Can I introduce to you Captain J.T. Coe of the Republic of Singapore Air Force and Captain Randy Micklejohn of the Canadian Armed Forces. For our preview exercise, we were tasked with assessing the Chinook against a specification. In addition to the handling tests, we flew instrument and night flying and assessed the aircraft during tactical low-level operations, which included load lifting and confined areas.
All operations with a risk of bird strikes.
As the transit height was reduced, the dangers from wires and bird strike would increase. The aircraft's ability to withstand bird strike could not be determined.
The Chinook presentation, like all the others, is classified, but the 3 students used some unclassified film shot for this series. They did not add a commentary or sound, which was to prove detrimental.
My portion of the presentation will deal with the Chinook's capabilities as it leaves the rear area for the second time, as it continues on a typical mission sortie. For its first task, then, the Chinook will be transporting internally a Ferret Scout car. As shown here, the Ferret can be driven directly into the cargo compartment of the aircraft.
The presentations are seen as a shop window for the fledgling test pilots. They are able to display their fitness for their future careers to their prospective employers.
I'm looking for somebody who can relate the work he does here and the product that he's working on, the aircraft or the equipment, directly to the way it'll be used on the front line. It's no good having, especially at this establishment, at Boscombe Down, people who get stuck into academics to the extent that they lose sight of the reason for their being here, and that is to, in a sense, safeguard the interests of the operator on the front line and to ensure that at the end of the day we're able to make the best of the equipment which is being procured for the services.
Gentlemen, we identified a number of deficiencies during our preview which made the Chinook unacceptable for the medium support helicopter role. If you have any questions, I'd be grateful if you'd address them through me.
Thank you very much indeed, team. If I can lead off with the first question.
The Chinook preview tutor, Squadron Leader Ian Young. Again, the questions, testing the quality of understanding. All part of the presentation and the final assessment of the students as test pilots.
To the battle area.
Yes, that was a problem which we encountered, well, not a problem, but the aircraft control response was sluggish at that weight, and we felt that at high all-up weights you may not have sufficient control response to operate at low level. In addition to that, vibration levels are obviously increased at high weight, and also we had some experience with the Lord mounts breaking along.
The questions go on. A good sign, as is the applause at the end. But the real test comes later, when the tutors meet to discuss the work and award the vital marks.
Timing was spot on, Mike, at
excellent, yeah.
40 minutes.
40 minutes, exactly. So for that, they get an excellent mark. The visual aids, what did you think of the visual aids? The prepared slides are very good, and it gave a good feel for the operation of the aircraft in the forward area. My only area of concern, I think, was with the use of that film clip in the middle. which could have been relevant if it was talked over properly, but it seemed that it was something that was just put in as an afterthought, and the audience were left watching something without any sound for about a minute or so, without any real constructive comment from the team. Otherwise, the VAs, the visual aids, were extremely good. It was a bit disjointed there, wasn't it? A little disjointed, yeah. But they handled them well, didn't they? So I think that comes into the very good category. Indeed, so yeah. no problem there. The content and understanding of the subject, I thought it came across quite well there.
Dave Southwood, who together previewed the F-18 Hornet in America, had a difficult task. The aircraft was a highly classified prototype and went unserviceable, reducing the permitted 10 hours of test flying to only 8. Nevertheless, Dave and Harry managed to produce their presentation.
Sir, gentlemen, good afternoon. This presentation is on a preview assessment of the TFA-18A Hornet performed by myself, Flight Lieutenant Dave Southwood, and my colleague, Hauptmann Harold Fehl of the Deutsche Luftwaffe. The presentation is classified restricted. The preview was carried out to evaluate the two-seat Hornet as a trainer variant for the all-weather, low-altitude strike attack role, with a secondary all-weather fighter role. The aircraft was a two-seat tandem trainer variant of the single-seat aircraft with full mission capability.
The presentations are the culmination of the course. There are prizes to be won, but there are no grades. Students either pass or fail, though everything they do, up to and including the presentations, is relevant. Is there a definite cut-off point below which students are failed?
I wouldn't say that we had any firm level at which we say he passes or not. It's very much a feeling from all the members of staff, from the very close look we get at him over a year, and it's a feeling of confidence in him.
Sir, gentlemen, the Hornet's handling characteristics. Ground handling. The aircraft was steered on the ground by use of nose-wheel steering. The excellent 360-degree field of view allowed to clear both wingtips during ground operations. The only unsatisfactory item found was the selectable nose-wheel steering high mode. This mode gave a very small turn radius of 30 feet, but gave very jerky input.
The joint presentation continues. The Hornet is not a well-known aircraft in Europe. Consequently, interest in the syndicate's findings is genuine.
A further 64 unsatisfactory features were identified and should be improved. Although the Hornet was unacceptable for the assigned roles, the comprehensive weapon system gave it good potential. Gentlemen, this concludes our presentation. We would now be glad to answer questions.
Now, this airplane has an unusual cockpit configuration.
Vic Lockwood was the preview tutor. He flew the Hornet and knows its complex computerized instrumentation.
Impulsive warning to the pilot of an emergency.
There were some major warning conventional type of displays either side of the head-up display, but most cautions came up on the left digital display indicator. The cautions came up as green words on top of green symbology on the background, and very often two or three or four letter groups would come up to indicate what the nature of the problem was. And this was also very confusing on top of all the green symbology, especially as the stores management display that was normally on the left DDI had lots of information on it.
Do you have any problems with the programming of that in the flight envelope?
None at all. It worked very well. And even with very harsh rapid inputs, there was no noticeable adverse yaw. And it really was very easy to roll out precisely on a head.
There is, at the conclusion, no doubt that this presentation has gone well, despite the difficulties.
The team have done a very good job on the aircraft. And thank you very much for this afternoon's presentation. Well
done. I thought it was very good. It's an incredibly difficult task. It's a very, very complex airplane that it was very, very difficult to present in such a short space of time. And I think being presented with that task, they did very well indeed.
It was interesting because it was a pre-production model again, and it was one that an early stage of its development. And so it was very interesting to see what an aircraft like that went through, and I think they did an extremely good job to find out all the problems they did.
And so the 44th course of the Empire Test Pilot School draws to its end. All the students have passed. The ones from the UK will be posted for a 3-year tour to the British test centres.
Well, at Farnborough and Bedford, they'll be doing pure research into flight systems, aerodynamics, stability control, modern control systems, modern weapon systems. This is research that's aimed at 15 years ahead, and will eventually be picked up by the manufacturers and hopefully incorporated in next generation aircraft. The test pilots at Boscombe Down are dealing with a much nearer future. They're dealing with what we call release to service, i.e. assessing an aircraft for its role and defining the flight envelope and the techniques that the frontline pilots will be using whilst operating that aircraft.
For the moment, all that now remains is the traditional formal dinner in the Boscombe Down mess, when the certificates and prizes are awarded, the premier prize being the coveted McKenna Trophy.
The McKenna salutes the man who's done very well and come out on the top of the course overall. And we find that he's a worthy winner. Normally the other students say, yes, he's the man that should get it.
All the staff and guests are present. Most of the officers here are test pilots or ex-test pilots, including the guest of honor, Admiral Sir Raymond Ligo. The dinner is, however, strictly stag. Well, almost. All the overseas students can invite their air attaché. Singapore doesn't have an air attaché in London, so JT invited the first secretary, Madame Lu, only the second lady ever to attend a McKenna.
Mr. President, Admiral Ligo, Air Marshal Rogers, Commandant, distinguished guests, lady and gentlemen. Since 1945, the McKenna dinner has been held annually to celebrate the metamorphosis of the graduating course into fully fledged test pilots and to present trophies to those who appear to have performed this wriggling act best.
The highlight of the evening, the presentation of the prizes introduced by the boss, Wing Commander John Bolton. But first, a tradition to be observed.
Thank you, sir, lady and gentlemen. As boss of this school, I must ensure that I'm properly dressed for the occasion. Mr. Roberts, the Titfer, please. This end, I think. Thank you very much. So, the Titfer was presented to the school for use on such occasions by Air Marshal Sir Ralph Sawley in 1944. Sir Ralph was a distinguished test pilot of the 20s and 30s and a previous commandant of this establishment. Tonight we graduate 10 fixed-wing and 5 rotary-wing test pilots. As you've heard, they've been a well-motivated bunch and were well led by their senior student, Squadron Leader Robin Tidyman. It has been a pleasure to have them here. Amongst the group, we have our first graduate from Singapore, and for the first time since 1945, we have a New Zealander on the course. Having listened to him after a party at Easter's extol the virtues of early aerodynamic research supposedly performed in Maori wind tunnels, I think it might be another 42 years before we accept another one. Now, the Americans are renowned for being laid back. How is this for a cool test pilot? Tom Coulter came to me during the spinning phase of the course in all seriousness and said, "Boss, if the weather's bad tomorrow and I can't do that spinning trip, I'm going to get married." And he did. I ask you, sir, to honor the school by presenting the graduation certificates. Firstly, to number 44, fixed-wing course. Commandant Serge Aubert of the French Air Force.
Serge is to join a French Air Force trials team in Britain.
Flight Lieutenant Nick Coulson, Australian Air Force.
Nick will be test flying heavy transports from Edinburgh, South Australia.
Lieutenant Harry Fail of the German Air Force.
Who will be at Manching, working with the Tornado test team.
Lieutenant Tom Coulter, United States Navy.
Tom is to join a U.S. Navy aircraft carrier suitability unit at Patuxent River.
Flight Lieutenant Jim Ludford, Royal Air Force.
is to become a member of a trial squadron at Boscombe Down, working on advanced Harrier projects.
Flight Lieutenant Steve Moore, Royal New Zealand Air Force.
Steve is now New Zealand's one and only serving military test pilot.
Squadron Leader Robin Tidyman, Royal Air Force.
Robin is to be part of the Boscombe Down team, developing the RAF's TriStar tanker transports.
Major Mirko Zuliani, Italian Air Force.
The popular Italian will be at Pratica di Mare, Rome, testing Tornadoes.
And now the members of number 23 Rotary Wing Course. Lieutenant Al Howden, Royal Navy.
Al is destined for D Squadron here at Boscombe Down for helicopter trials.
Captain Ko Yun Tae, Singapore Air Force.
And his former preview colleague, JT, will be doing similar work in Singapore.
And finally, Captain Randy Meiklejohn, Canadian Armed Forces.
The Canadian is posted to a test centre with the rather appropriate name Cold Lake. Apart from their certificates, several prizes were also awarded. Les Evans and Serge Aubert took the Hawker Hunter Trophy, awarded for the best preview. A moment of satisfaction, as they were two-thirds of a syndicate which only 2 months previously had delivered the worst. Les will be testing Harrier systems at Bedford. Bob Horton, who is also posted to Bedford, received the Westland Trophy, presented to the Rotary Wing student, considered to be the runner-up to the major prize.
Finally, the McKenna Trophy. The trophy is awarded to the best all-round student. I ask our guest of honour to present this coveted award to Flight Lieutenant Dave Southwood, Royal Air Force. Thank you, sir. Our congratulations again.
For most, the only tangible reward is the certificate. That and the right to add the letters TP after their name. And, of course, the relief that it is all finally over.
I don't care what they say about Westlands. I think they're all right.
But I had no friend. This electric.
You'd like to start over and do it again?
No. Yes, if I can use the same reports as this year. Just for the flying.
I'm very glad the course is over. Very glad.
Well worth it.
Here's to it.